Welcome, everyone. If you haven't done so already, I would recommend that you sign up for Ripple and you also create a fork of the workshop project. That's where we're going to be working today. The reason why it's because Ripple is an online platform. That means that you don't have to install Python on your computer or do anything of that, which obviously requires some time to do that setup, but it also can be hard to troubleshoot if you're having any problems. You didn't add Python to your path. That's going to give you trouble when trying to run stuff on the command line. And then, there's just so many variables and so many things. So I like this platform because it just makes it the same for everyone. And one of the first things that I wanted to do is launch this quick poll. It's just one question. And essentially, I just would like to know what's everyone's kind of like previous experience with when it comes to programming. The workshop is designed to bring you up from literally nothing. So even if you had no programming experience, then that's totally fine. Like, we're gonna be learning that. If you know another programming language really well, then there's gonna be a lot of stuff that's gonna be very basic and maybe a little bit boring to you. So I am sorry about that. Feel free to open something else on the side while you wait for the good stuff to come. But I think even if you know another programming language very well, or even if you know a little bit of Python, I think hopefully you'll be able to learn a few quick things that maybe you didn't know. And if you know the very basics, then once again, like there will be some items that you'll be familiar with. It's just that you're going to be implementing them within the context of Python. Python does things in a slightly different way to other programming languages. Syntax is one of the big things, but then there's a lot of other convenience things that you're going to notice. So I don't know, like I hope that you learn something today, and that by the end of the workshop, you're able to write an entire Python script on your own. There's a lot of stuff that I won't be able to cover, and maybe we can feel free to ask those questions at the very end. Kind of like the what's next, right? Like where to go from here. But once again, like the focus in what I'm going to try to mainly do today is get you started with the basics of programming in the context of Python, and be like take you to the point where you can write a Python script. So it seems like it's there's quite a few with no experience, quite a few with that know another programming language very well, which means you're probably just trying to get another language going, in this case Python, and others that know the very basics. So it's really good stuff to know. I'll keep that in mind. Fair enough. I try to add the answers that I thought about, but that's true. There's probably a few other answers there already. So that's good. So I can just quickly share the responses, but that's what it looks like, which is good to know. So I'll try to keep that in mind. So as we go and we learn some of this stuff, I can touch on a few items for those who already know their programming language very well. Fantastic. Already. So let's get started. Another thing is I'll try to have 15-minute breaks every hour or something like that. Otherwise, we're all going to get tired very quickly. And as I mentioned, feel free to interrupt and post questions in the chat or raise your hand. If I'm going too slow, if I'm going too quick, please also let me know. All of that is always very helpful. Alrighty. So with all of that being said, I think I'll just turn things over. I mean, I don't really have much slides. My entire content is here. And I think that's a nice thing too about the platform, like this platform that you can just, keep working on. It's very fun to do things here because you don't have to worry about any setup, any installations. But at the same time, when you get to a certain point, you probably want to switch to something more conventional, which would be actually installing Python on your own computer and installing an IDE, which would be like similar to this editor that we're going to be working with today. But there's a lot of information online on how to do it and how to get started with Python in that sense. So, today we just want to jump in. So what you're going to notice is that there's quite a few things up here. I have a few .md, which is markdown. And these files are just will just provide you some information. One nice thing about Replit is that you can have a preview. So this is this is the actual content. But if you go into the preview mode, it looks prettier. And this just first gives you some information about Replit, everything that I've just mentioned. And if you, for example, some people want to be able to run Python on a cluster, maybe it's an Alliance cluster. If that's the case, there's a whole guide here that I'm linking to. So once again, this is just the basics of the programming language itself. In terms of the environment, you're going to see the side panels. You're going to see different tools and stuff that you can use. Today, we're not going to be using a lot of these, but there's a lot of stuff to explore here. Really fun stuff. Then you have your files, and this is how you can, you can create files, folders, move things around. We have some settings, and if I'm not mistaken, that is part of the tools. So that's the settings. And one thing that I want to make sure everyone has enabled is the code intelligence, because that way you're going to get some hints as you're typing stuff, which is always really, really helpful. The other thing that I wanted to bring up, I'll just keep this file on, is there's also the console, and the console is where we're going to see any output from our code. By default, you may not see it, but you can always bring it up by clicking on the console tool. That will bring up a tab. You can move this tab if you always want to keep it on the side. And when you hit run, you're going to see all the output here. So that's another thing to mention. Then you have the editor, which basically anytime you open a file, you'll be able to edit it, in this case, main, and then, you can start typing stuff. And then a few extra things about the console. This console is very special in the sense that when you run something, and maybe the best way to see this is once we actually start working on it. But it's a nice console because you can actually run stuff, and then after it has finished its execution, you can still keep going on the console. So the script can do something, and then you can still play with it. And I'm going to be using it because I think it's a nice thing. So it's a pretty fun thing that you don't see on your typical IDE setup if you've programmed in it before for other programming languages. And then finally, the run button, which is up here at the very center, and then that is basically what's going to allow you to run stuff. So that's basically the very basics of Replit. And I think that over the years, they've made changes to the platform to make it really intuitive. So with that being said, I think I'll bring up the console just because this first bit of the course can be done really, really quickly without having to write a script and then run it. You can do it quite literally right from here, although I'm not seeing... Okay, there we go. I should be able to just hopefully it should be good. All right, yeah, that's good. Already, so some of the basics, and we always got to start is with the data types. So in our human terms, we have this concept of what is a number, what is text, what is a true false or a yes no, like when we're trying to make a decision. And all of these things make sense in our human world, but to computers, there needs to be some sort of translation so that the computer knows, for example, the difference between an 88 being used as a string, being used as text, and an 88 being used as something that you want to make calculations with. And all programming languages will have similar, I mean, there will probably have almost the same types. And some programming languages, they go very, very specific, especially with numbers. And in the case of Python, I think that things are pretty standard. If you know another programming language, this is probably nothing new to you. So the first one is the concept of a string, which for us, it just means text. So in order for Python to know that we're trying to specify that, hey, this is a piece of text, you need to use, I mean, you can use a few different things. In this case, I'm going to use the double quotes, and I can just type my name. In this case, the console, when I type that in and I hit enter, it is just going to return me what I just gave it. So nothing funny happens. But as you can see, it's working. If I just try to type my name just like this, we're going to get an error because it's saying, hey, I don't understand what you're trying to tell me. In this case, it's thinking that you're trying to look for a variable. And we're going to be learning about that in a sec. But that is the importance of being able to understand how this programming language wants you to enter a certain thing. And it's important for you to tell it exactly what you want it to interpret this as. In this case, Fernando, please interpret it as text. And in order to do that, I need to give it double quotes. Then for numbers, actually, there's a distinction between the concept of an integer, such as 88, and the concept of a float, which is something like this. I mean, in this case, they look pretty much the same, and to us, they're numbers. Yes, we can classify them, but for computers, they actually, the way that they store it in memory is different if it's an integer or a float. And therefore, it is important for them to know exactly what you mean. Once again, the way you define it, it's pretty much the same. But if you use, and this is in the try to yourself section, so you can play with this in a sec. There's this type thing, and we're going to learn soon what is this whole thing. But essentially, if I say type, and then I open parentheses, and then in the middle I put something like 88, you're going to see that it says, hey, this is an int. An int is for integer. But if it's an 88.5, I get a float. So the way that we define it is the same, but the way that it gets interpreted by Python is different. So some fun stuff to do. And then finally, Boolean, and this we're going to be working with this later on. But it is the concept of true or false, or yes or no. In the case of other programming languages, it might be lowercase, or it might look different, or maybe you just use 0 and 1. But in this case, it's true with a capital T. If you try to do it with a lowercase t, you're going to get an error, and same thing with false. So yeah, so those are the very first types that we're going to be learning about. And I'll give you a few minutes to play with it, try it yourself. So as I mentioned here, you can experiment with type, and you can see if there's a difference between using single quotes or double quotes, and see if you can mix and match too. So I'll give you a few minutes to play with it. So just going over these items from try it yourself section. Once again, like type, it's a function, and we're going to be learning about functions soon. But anything you put in like between parentheses, it will give you the type of whatever it is. So that's what type does. And then the difference between these two is none. Like you can use single quotes or double quotes to tell Python what you're trying to, a text that you're trying to define. The important thing to keep in mind here is that in certain situations, you may prefer one over the other. For example, if you're typing something that has in this situation, if you try to do it with single quotes, Python is going to think that the very first one, that your actual string is just ISN. And then it's not going to be able to interpret this correctly, and it's going to throw an error. It's going to be an invalid syntax. So these are certain situations where you might prefer one over the other. So, and then the answer to this one is that you can't mix and match. You have to use the same. And there's other ways of specifying strings, but I think for now this is all you need. So then the next logical point to go to is the concept of a variable. And basically with a variable, you can store, maybe it's you defined string and you can store it in a variable. And the nice thing about it is then you can use the variable somewhere else, and it's almost as if you're using that same string. So it's very nice in that sense, and you use them a lot. And you define them in very different ways in other programming languages. In some of them, you have to specify exactly what it is, the type. In this case, in Python, there's basically no typing, so it can just be anything. And the way that you define it is by typing some sort of, anything. In this case, I've used the example of var1 is equal to 100. And now that variable is 100. So if I just say var1, it's going to return me the value of it. If I hit enter, it's going to give me the 100. And I can redefine it. I can say var1 is now going to be Fernando. And now the value of var1 has changed. If I do var1, it's going to be this. And then I have a quick example here where, let's switch var1 back to 100. I can have var2, which is equal to 200. And then I can do operations on the two of them and then store that in 1/3 variable, where it's var1, in this case maybe plus var2. And then sure enough, var3 is going to be 300. So it's just somewhere where you can store information. And I'll give you another few minutes here to do the try it yourself. And then I can walk through each example. All right. So there's just a quick question here about the spaces. Yes, there's a bit of preference here. Doing it this way will also work. It's just a preference thing. Spaces, though, in Python are important, but we're going to see that in a moment, and that just matters when you're creating a script like this, and we're going to be learning about in a second. So yeah, we'll get there soon. But yeah, getting back to the items here in the try it yourself section. So the first one is, if you redefine var2 after defining var3, will var3 change? And what that means is saying something like, var2 is equal to, in this context, it just means, similar to how we had var1 be 100, var2 200, and then var3 is this. So var3 is still 300. And basically it meant, hey, if we change var2 to be something like 500, will that change the value of var3? Because var3 in theory is var1 plus var2. And the answer is no, because the moment you define it here, that's when var3 gets its value, and that value remains unless you change it again. So yeah, so it's not like it's a dynamic thing where all the time it's going to be defined that way. It's just at the moment of defining it, that's when it gets that value, and that is the value that remains. Then this is an example where one variable is a number and the other variable is text. And then what happens if you do any sort of operation between them? In some programming languages, it will concatenate them as strings or something like that. In this particular case, you're going to get an error because you're trying to do an operation between two items that have different types. So that is why it won't work. Then there's this really fun notation. var1 is equal to var2 is equal to 50. And this will work. And what this is saying is that var2 will be equals to 50. And var1 will be equal to var2, which is 50. So in the end, all of them will be 50. And then there's this other fun notation. And this notation and we're going to be learning about this later on. But you're kind of like unpacking the, you're defining 150, comma 50, and then those are getting, the 100 will end up in bar one, and the 50 will end up in bar two. And we're going to be learning about this way later on. It's just, I think it's a fun thing. Also, something that I wanted to mention is if you ever want to copy and paste stuff here, you'll have to use Control Insert for copy and then Shift Insert to paste. Awesome. So yeah, so that's that. Now we can move to the next section, which is the print function. This one's it's a very important one because I mean, so far in this console, anytime you type something like var2, it returns the value of that. But when you're working from a file, you won't see output unless you tell the script to actually output something. So if I were to copy the code that we have here, say this one, and I run it, and I just quickly stop it, I can clear the history, and I can rerun. So you can see that nothing happened. This is the code intelligence kicking in, telling me, hey, don't you want to output something? So you can see that nothing has happened. And that's because script, each line it runs, you don't get anything unless you tell it to. And one way in which you can tell it to return something is through the print function. And so you can say print and then var3. And if I run this again, this time we do get 105, which is what we should expect var3 to be in this case. So that is how that works. And so print is a function. We're going to be learning about functions soon. But once again, in those parentheses, you can put anything and it will print it out as a string. So, and you can print also multiple elements. So you can do like, in this case, I'm printing a string and then comma and then a variable, and by default the spacing between the first item and second item will be a space, so there's going to be a space in the middle, but you can change that, and you can put as many items as you want here. So you could keep like comma and then print something else, comma, print something else. So that's the print function, and once again I'll give you some minutes here to play with try it yourself. But essentially, so this is one of those things that is more just for Ripple. So Ripple, because it does a lot of stuff for you, so you don't have to do it yourself. One of the things it determines is that main.py is the file that it's going to run. So whenever you click on start on run, that's the file that it runs. But I mean, I can create multiple files within here, and I can import variables or stuff like that, or functions from those files. And I mean, when you're working on it on your own computer, you can actually determine what is the file that is going to run. You can decide which one you want to run. So yeah, so that's how I would explain what .py file is. It's just you can run any .py file as Python script. So the difference between a .py and a .md, yes. So it's a different file types. So just like here, we have a .csv, which we're going to be playing with later in the workshop. You have .py. This is this is basically a Python script, and then you have a .md, and a .md is a markdown file. And what a markdown file is, it's just essentially, I mean, really, it's just text. This is what it actually is. But Markdown allows you to, I would say that it's kind of like a very extremely simplified text to HTML format that was created to simplify creating, documentation pages and stuff like that. So, so this is just purely for documentation, and in this case, to provide all the content for the workshop. But yeah, like the actual Python stuff here is the .py. There's a packager files down here. This, I don't think you can do much with it. This is something that is automatically done by Replit, but essentially, and it's for managing the environment. So ideally, anytime you create a Python project, you want to keep all the dependencies within the same place. So in this case, what would be a good example? I think the package, I mean, there's quite a few dependencies here. Maybe the easier one would be this one. But essentially, you can keep all the dependencies in one same place. And actually, this is the way it would work. So yeah, it's poetry.dependencies. So in this case, for example, for this project, we're going to be using, I mean, we have Python. Then we're going to be using also pandas. We haven't learned about this, but we'll learn about it later in Matplotlib. So and this, you don't have to add it manually. This does it on its own in the case of Replit. But it allows us to keep our dependencies, together and determine what should be the versions for those dependencies. And this just allows you to, like, it's for portability purposes, so that different people can create the exact same environment. And in this case, what is managing this whole thing is called Poetry. So you can Google poetry Python and then learn about it. And that's when some people use, for example, Anaconda is one way of managing managing environments, and you may have learned about that. And then in other programming languages, there's many others like Composer. I think in PHP, Yarn, or npm in JavaScript, et cetera, et cetera. So those are kind of like the files that you're able to see. But for the, what really matters here is the .py. That's the actual script. Then there's a question about being able to copy the code like I did. Yes, so I can show again. So let's say I want to copy this. So you can just copy it to the clipboard. That's easy enough. In this case here, this one, I think you can do Control V, like how you would normally copy. What I was saying is for the console. If you're using the console here, you do have to use Control Insert to copy and Shift Insert to paste. But as long as you're working here, Control V should do the work, or Command V if you're using like an Apple-based computer. And yeah, let me know if you're able to copy and paste. All right, and it sounds like what I described sounded like a notebook in R, so we're going to say that yes, it is. And then thank you very much for the explanation of the Markdown file. And yes, that's correct. Like a Markdown file can be created, I mean, pretty much anywhere, as long as something can interpret it and put it in pretty HTML. Perfect. And the copy and paste instructions again, that's right. So I think I'll actually put them here in the chat just so everyone has them. So I mean, there are two copy and paste. Paste. So it will either be Control plus C, Control plus V. That's the classic. And the second way to copy paste is Shift plus Insert. To copy, Insert, Shift plus Insert. And there we go. So Control Insert would be the copy command, and the Shift Insert would be the paste command. But once again, that second way, you would only need it in the console, which from this point forward, I don't think we'll be using anymore. But yeah. So going back to the try it yourself section, this was just an example of print. And as I mentioned, by default, there's going to be a space between hello and world. If you just print it like that, comma separated, but then I'm establishing here that there is an optional argument, and we're going to be learning about this when we get to functions. And if you put sep equals and then any string, that is going to be the string that's going to be separating anything that you pass here. So sep stands for separator, and yeah, and you have to make sure that this goes after anything that doesn't have sep equals or something equals, essentially. And we're going to learn why later when we get to the functions, which is it's coming up very soon. And then the other optional argument is it's end. So that means what is going to happen once it finishes printing all of this. So you can decide what that is going to do. I think by default, it's going to be a new line, meaning that it's going to go, to the next line. But you can change that. So it's something different. So that those were the two examples there with the print command. Perfect. So something that I wanted to get to, and this is also another different type, essentially, and that is the concept of a list. In other programming languages, you may know it as an array. And yes, and a list in Python are very nice because they can just hold anything, absolutely anything. So here's an example of a list, and just insert. And with that, I've defined list, and the list contains a few different things. So you can see that we have two integers, we have two strings that have been defined in different ways, and we have two booleans. And sure enough, if I say, hey, tell me what it is, you can see that that's what it is. And now comes the next, now you've defined a list, and the way that you typically will use a list is, to store information and then to be able to iterate over it and operate on it or do other types of stuff with it. And so typically you'll want to be able to access those items. And the way that you typically do it is by using their index. So when we define this list, we actually did a few extra things behind the scenes. So we determine an order for these items. And in that order that we added them, they've been defined an index that matches that order. So the index, as in many other programming languages, it starts from 0. So then the first element will have the index of 0. Then this one will have the index of 1, 2, 3, 4, and 5. So those will be the indexes for all these items. And in this case, we're going to learn a new thing that will, in functions, we've learned the parentheses to execute something, and we're going to learn about that in more detail in the functions section. But here we're going to use the square brackets, this funny notation, and then basically we can put in those the square brackets what is the index of the item that we're trying to access. So we go back to list 1, and then we use the square brackets to specify, hey, I want to retrieve something from here. And then in this case, for example, if I type the 2, it's going to be the element 0, 1, and 2. So it's going to be A, and that's what we get back. So that's the way that works. And then there's a few extra variations on this. You can do this funny notation where you do 2, and then you use a colon, and then 5. And this is how you get a range of values. So if I do 2 to 5, and this is a very important thing. So it will include the element at position 2, but it won't include the element at position 5. It's actually going to stop 1 before that. So in this particular case, it would start at A, which is our element number 3. Then it goes 4. And then this is 5, so it's going to stop 1 before that. 1, 2, 3. Actually, I'm doing this wrong. 0, 1, 2. So 2, 3, 4. And then this is 5. So then it's going to stop at 4, which means that the elements that it's going to return are A, B, and true. When I run this, that's exactly what happens. So that's just something to keep in mind. If you want to get to all the way to the end, something that you can do is you can say, I'm not going to include that item. I'm still going to include the colon, but not going to specify that. And if I do it this time, it will include false. I can also say, actually, I do want to go all the way to in this case, true. But I wanted to start at the very beginning, and I can just delete that number. Now it's going to get all the way from 1 to true. And the final variation on this is to add yet another colon and another integer, and this is going to represent the step. And in this case, if I do it, if I do it this way, so once again, we're going to be accessing from 2 to 5, just like we've done. But in this case, we're saying that our step is 2, which means that it's going to skip an element. So it's going to take the A, it's going to skip the B, and then it's going to go to true, which means that in the end, we're just going to end up with A true. And if I hit enter, that is what we get. So so that is how that works. And now I can give you some minutes to play with it and all these different variations. Don't get too caught up on the fancy variations of this. Typically, you just access a single item, but it's fun to know that you can access ranges and even specify a step. All right. So in the interest of time, I'll get through the try it yourself. Then we'll go to dictionaries, and then at that point we can take a 15-minute break. Um, so in the first example is what happens when you try a list and then you don't enter a start or a from and a to. You just specify the colon. And what you're going to get is you're going to pretty much get everything. So it will be the same as using just list one. So that's what happens. And then the second question is, hey, can lists contain other lists? And the answer is 100%. So in this case, we have one, then the second element is a list, and the third element is a three. And then the way that you would access this list is, by saying list one and then square brackets and then index one, because we're starting from zero. And with that one, now you get you get a list. So now that means that you can also access elements in that list. So then you can chain another square brackets, and then you can specify the index, but now it's going to be based on this list. So if you specified 0, you're going to get an A, and if you specify 1, you're going to get a B, and that's what this is doing. So this is accessing that A, and if this was a 1, we would be accessing a B. So that's pretty much it for lists. And then we have the concept of a dictionary. A dictionary is actually not too different from the concept of a list. A dictionary, as I mentioned, where we use lists is, we store elements in there and eventually want to iterate over them. That is typically what we do with lists. In the case of dictionaries, it works in a slightly different way. We're still storing information in the same thing, in the same container, but in this case, we're providing a key to identify it, to be able to retrieve it later. So once again, I would say that the equivalent of a key is equivalent of an index in a list, right? So a list, each item has a key, it has its index, and then that index corresponds to the value that you've stored. In this case, it's kind of like the same thing, but you're specifying a key, which typically will be a string. So it's good to store information like this. For example, if I want to create a dictionary of people, right? Then I can create this dictionary will represent a person, and the notation for it is curly brackets, and then I can say, this person, the name is Mike, and the age is 27. So that is the notation for it. And in the same way that you access items in a list using that square bracket notation, you do the same here. But instead of passing an integer, because now the key is it's not an index, right? In this case, we provided a specific key that it's a string. So therefore, that is what you pass. So in this case, name will be able to retrieve Mike, and with age, we'll be able to retrieve 27. And just to showcase this a bit more, another thing here is technically you can structure this however you like, as long as you are within those square brackets. Within those curly brackets, you can put it like this. That's totally works. I like doing this just because I think it looks slightly more organized. Let's say that I wanted to add another field, right? Like occupation. I could do that, and then I can determine, I don't know, developer. So that's how a dictionary works. And I think that in the example, yeah. So in the example, we'll see this in a second, but just like a list, just like it can hold anything, maybe the occupation is occupations because this person has multiple ones. And in that situation, I can do something like this, and now it's a list, right? And then I can say that it's a developer and, I don't know, musician. There we go. But once again, like the important bit here is you can hold information. You can hold pretty much anything. It can be a number, it can be a string, it can be a list, and yes, it can be yet another one. It's cool that it's trying to tell you So you can keep going like that and make up some stuff. So real cool stuff about dictionaries. And the cool thing about dictionaries too is that I'll just remove this to make it simple. Is that we can create we're going to call this this is going to be my friend, and I can also say this is going to be my mom. And maybe I can use the same. I can use the same structure here. All right. And then we can create a list of, let's call it, yeah, we'll just call it people. And this can be a list where I put my friend and I put my mom. So once again, you can nest things like this. And you can play with these. And we'll be playing with this very soon. So these are just a few examples on dictionaries and how you can mix them up with lists. So with that being mentioned, let's take a 15-minute break. I guess we can get back at 10:25. And in the meantime, feel free to play with dictionaries and lists and anything we've learned. This is pretty much like all the important types that you need to know: lists, dictionaries, strings, booleans, etc., etc. And now you know how to find them and how to use them. From here on, it's just a matter of how to put them together in different ways to create logic and to make your script do fun things. So when we get back at 10:25, it's going to be functions, classes, and all the other fun stuff. So from here on, it's when the serious stuff kicks in. Just a quick question: will we only be coding in the console today, or will we also learn how to code in the pipe? Just curious. Yes. So far, I've been there's been some stuff that it's easier to just run it immediately in the console. But I mean, pretty much from this point forward, we'll need the .py file to be able to do the rest of the stuff. So yeah. So let's jump into the functions. So we've actually already briefly mentioned, the print and the type functions. And talked about arguments and stuff like that without really explaining what they are. But basically, the concept of a function is to be able to summarize a series of steps in a compact form. And so you define a function using the DEF syntax. And then the next thing that we do is that we give our function a name, and that can just be any piece of text. In Python, we typically use what's called a snake case. In other programming languages, you'll find something like camel case or anything like that. And what snake case means is that everything's going to be lowercase, at least for functions, for the name of functions. And instead of a space or something like that, you'll use an underscore. That's what snake case means. And then finally, what we have to define is parentheses. For now, we're just going to put parentheses. That's it. Then a colon. And then what the function, the content of the function is what's going to be right below it. Now, here is where spaces become important, because the indentation will be important. Typically, in Python, we work with an indentation of 4 spaces. And then anything that's within those 4 spaces will be in the function. Anything that's out there, it won't. So here is a quick example. I'll just copy and paste this in here. All right. So, and this is what I'm talking about. So if I do this, print now is outside of the function. I press tab, and now it's inside the function. It's a very subtle distinction, but nonetheless, it's a very important one. So in other programming languages, you'll find stuff like this. and then anything that's in there, it's going to be part of the function. In the case of Python, it's a colon, and then indentation is very important. So this, once again, is still part of the function, but this is not. So really important distinction to make. So here we go. So this is a function. It's called say hello, and then we're just printing hello. That's what the function does. So if I just run it, nothing's going to be printed or anything, because this is just a definition of the function. It's just being defined. It hasn't been called. In order to actually call it, you need to use it just like we've used the type or the print functions. In those, you needed to pass something in the middle. But here, when we define this function, we just put the parentheses. Here's where we're going to put arguments. At the moment, we're not doing that. So this is how you execute the actual function. It's just the name of the function plus parentheses. And then if I run that, this time it will actually print hello. So you can see that this time it worked. Another important distinction is that say hello can't be executed before it's defined, because if this happens, you're going to get an error with saying, hey, I don't know what say hello is. So there's the importance of the order in which you type these things. And that is how you do the most basic of functions. We're just printing something, and then we're just, that's what it does. Now let's introduce a little bit more complex. So here's another example where we can return stuff. So a function can do stuff like print, but it's more useful when you're actually returning stuff. So maybe you do a set of operations, you run an algorithm, you do something else, and then at the very end you return your result. In this case, we're going to hard code a 200, and we're going to say, we're going to call this calc. So what is it calculating? Doesn't matter. So we're executing this function, and then the result from it needs to be stored somewhere. So I'm going to store it in res equals calc. So I'm defining this variable, and this variable is going to take whatever value is returned by calc. And now that I have that, I can say print res, and if I rerun this thing, I could just probably, we're going to get that 200. So what happened here, right, is calc defined the function, then we actually execute it, and we store the result in res, and then we print res. That's the sequence. Once again, these parentheses are really important. If I do something like this, it's not going to work. Res, it takes the value of the function, which is a function called calc, and this is the location memory. So not too useful. So that is important. So perfect. So now we know that we can return stuff from a function opposed to just doing something, which is really useful. But then this function will always do the same, and that is not necessarily very useful. Therefore, we can switch to a more, let's see if this works. Right. Perfect. We just had to move things around a bit. Wonderful. So now the next step is, hey, let's make this a little more useful, in the sense that now we can do more complex stuff with it. And the way that we're going to do this is by introducing the concept. I don't know why this keeps going up. The concept of the concept of the arguments. So I'm going to copy this, and it always goes back to the beginning. That's very weird. If I do that, will it? Okay, I might have to use it like this. Yeah. Okay. We're going to use the concept of the arguments. So in this case, for example, this is going to be an extremely simple function. It is just going to sum two variables. And in this case, I'm saying it's going to be a variable A and then a variable B. Those are two variables that you need to give it. And so the function will first say, hey, the result is going to be equals to a plus b, and then I'm going to return that result. I could simplify this further. For example, I could do something like this, and then it's returning a plus b immediately. Both forms are fine. And then I can actually execute the function. So sum vars, and then I can say 5, 10. It's going to return something. And in this case, I'm going to save this in result. So it's going to look like this. And then I'm just going to print this. Which is going to be the result. So once again, this is going to execute 5, 10, and then it's going to print the result. This stuff, I'm going to comment it out. You can comment it out by using control and then the /. So that's what I'm going to do here. And then I can rerun this. You can see that we get 15, which is what we should expect, which is looking fine. And another way of running it, and that's the alternative syntax, right, is one where we're being more specific. We're saying, hey, A is going to be equals to 5 and B is going to be equal to 10. If we don't do this, then by default, right, it's going to assume that 5 is A and 10 is B. That's just because of the order of the arguments. But you can, once again, be more specific about it and say that you want A to be 5 and B to be 10. And if you do that, I mean, you're going to get the same result. Actually, I executed this, but I didn't actually store the result. So I could just do this. Perfect. And there we go. Now we get to see the exact same. And the good thing about being very specific is that you can change the order of these things. And if I change the order, I'm just going to do that. If you change the order, now I'm saying B, I'm defining B first and A last. But because I'm being specific about this, when I run this again, I mean, it's still going to work. It's still gonna do it the way it should be. So yeah, so that is when you actually wanna add some of it. Now, the next thing that we're gonna do is it's important to notice a few different things. In this case, when we define A and B, and we're using them inside here. And especially if you go back to the other form where we had a result equals A plus B, and then we will return the result. It's important to notice this is a variable that has been defined, and these are also variables, right? In the sense that I mean, you're using them as variables. They take the value of whatever it is that you pass when you execute that function. And what's important to mention here is that those variables are local. So here I have a quick example, for example, where we have a function. The function doesn't do much. It just defines a variable called result. But this result is local to this function, which means that if I execute this function and then I try to print result, it won't work. And the reason it won't work is because, once again, it's local. And so that is why we're getting this error of, result is not defined. So that is something that's important to mention. And now there's the opposite can happen though. You can create a variable outside, right? And this variable is global. Therefore, it means that you can actually use it within a function. And sure enough, if I run this, you're going to see that it's able to print it. So that is one very important distinction to know. And the other important thing to know is that you are not able to modify this variable in here. So if I say, actually, you know what? I want outside to be equals to hello. I execute this function, and then I print outside. The moment I define this as equals to hello, this is going to become like this is a local variable. The global variable will remain. It's just this one that will be changed. So if I run this again, you can see that I still get the original value that was determined up here. So just a few things that are good to keep in mind when working on it. The other thing that we can talk about is the distinction between a positional argument and an optional argument, and that's here's a good example. So in this case, once again, we're going back to that function that just adds two numbers together, and we could have a, and a, I'm not it's just how it was before, but this time I'm saying b equals 10. So now this means that b will have a default value, and that default value will be 10, which means that now it has a default value, therefore it isn't required. And you can see here that I can actually execute it like this. So I'm going to do res equals that, and I'm just going to print res. Perfect. So it's going to sum the variables, and then in this case, 5 will, a will become 5. And then because I'm not specifying b, then it will just, it will be 10 by default. So I can run this, and you can see that we get 15, which is what we expected. Now I can pass something like 20. Now we should be getting 25. And I can also say, b equals, and specify, and be very specific about it. And that is an optional argument. So good to keep in mind that you can give defaults to your functions. And that's pretty much some of the basics. There's more complex stuff here, but I think for now, this is pretty much what you're going to be typically seeing and using. So now you can try it yourself. So let's take a few minutes to go over that, and then I can walk you through each of those examples. All right, so I think I can walk through some of these examples and try it yourself. So we have here, this is the original function, which I've copied and pasted here. And then, the question is, what happens if you try to return more than one value? So in this case, instead of just returning the result, we try to return 3 variables, which correspond to word, the exclamation mark, and the actual result. So actually, this should be part of the function in there. And then I could just execute this function by saying res equals add excitement. Perfect. And then I'm going to print this. Should I need a word? Wonderful. So I can stop this, rerun it. And you can see that what I get is this weird thing that's in parentheses. This is a tuple. We're going to learn about them later, but they're not too different from a list. It's just a very limited list, basically. And you can see that we get 3 items. So first we get the actual result, then the original word, and then whatever is our exclamation string. And the cool thing about doing this, though, is that we can do this. And I'm just doing this for simplicity, but I can rename this to be anything I want. And if you recall from that very first example, when we were defining variables, where you would have var1, var2 equals 50, 100, here we're using the exact same principle, but doing it in a slightly different way, where this is returning 3 items, and therefore we can store them separately to 3 different variables. So I can rerun this, and there we go. So essentially what happened is that each one of them got the correct values, and then I'm just printing them together, and this is what you end up with. So there you go. That is what that example was all about. And then here's the example about, can you reassign a global variable inside a function? And this is something that I already that I already showcased, and the answer is no. Something that's from the outside, yes, you can use it in there inside a function, but you can't redefine it globally. Now, technically, there is a way. There's a way of doing it using the global thing, but there's like which looks something like this. But at that point, you're getting into more complex stuff. Like you're making it more complex. But yes, I guess you have the option if you really want to work with a global variable. So that takes us to the next topic, which is classes, and this one is one that I think it's good to know about. I don't think you're going to be defining like using a lot of classes by the end of this particular workshop, but it helps you understand how other stuff works, I guess, and that's why I always like to bring up this section and discuss it. So in this case, this is how I like to preface the concept of a class and the use case for it. Let's say that we want to create a phone book. And here's where things start coming together. So I'm creating a list. It's going to be an empty list. And that's going to be our phone book. Any contacts, we're going to be adding them there to that list. Then we're going to create a function. That function is going to be called add contact. And it's going to receive two arguments. The first one's going to be full name. The second one is going to be the phone number. So that's it. And then what we're doing is phone book.append. Don't worry too much about this. We're going to be learning about it soon. But what matters is that this allows us to add something to this. So the phone book, we're appending it. And I know I just mentioned that you can redefine global stuff from inside of a function, but this is we're not redefining. It's not like we're saying both phone book equals. We're using a method, which we're going to be learning very soon about it. So this is a slightly different thing. In this case, because we're using a method, you are able to modify this list from within this function. And then the way it works is that when we append, we're going to be appending a dictionary. And that dictionary is going to have two keys. The first one's going to be name and number. And then we're just going to be passing in whatever we passed as full name and phone number. So that's the way it works. And then I'm just executing, the add contact, and then I'm going to be not printing it yet because I'm going to be playing with it in the console. But I'll run this. So, and actually maybe it's better if I clear this. Perfect. So let's get the phone book. And there you go. You can see that the contact mom was added. Then let's say that I want to add a second contact. Well, I can use the function add contact. And then I can say, in this case, I'm going to add my dad. And then his phone number, we'll make it up. And I can close parentheses. And yeah, the question about the console is you can see the clear history button here. That's what you can click on, and that should clear it. Good question. So then if I execute this, it seems like nothing has happened, but if I grab the phone book again, you can see that now it has two contacts. So it has my mom and it also has my dad. So there we go. We have a functional phone book. You can only add contacts to it, but for what we're doing right now, this is really, really good. So this is great. But now let's say that we want to create two separate phone books. I want to have one for work and I want to have one for personal. Well, in that case, it kind of means that I just have to duplicate this, right? So I gotta copy this over, something like this, and then I can call this my work phone book. And then a work phone book is going to change this, and then add work contact. And now we have a work phone book and I would have an add a work contact function, and I would have the actual adding of it. So this, we're just copying code. And what if we want to be able to have an infinite number of phone books, right? Like where we just want to have as many phone books as we want. Well, this is not very, very nice. So this is where a class comes in. A class will allow us to essentially create a template of what a phone book should be and how it works and the logic within it. And then that will simplify the entire process of what we're trying to do this. So I'm going to clear this because I already have it's the exact same implementation that we have here, but as a class. So the way this works is we say class and then we give it a name. Typically for this situation, we do use camel case with the uppercase of the first letter. So phone book, typically you this is how you type it. So instead of spaces, this time it's kind of like the next word, you use the capital letter. This is snake case, camel case. Just conventions. You don't have to follow them though. And then we use the colon. And once again, we need this indentation. Otherwise, this won't be within that class. And there's a few things weird happening. This init, underscore, init, underscore. All that matters is that this is how we're defining that phone book property. And the way that it's happening is you're going to see this self. And this is a weird thing, I know, but essentially it means, itself as in the phone book itself. So in this case, we're saying self.context, and this dot notation, we haven't seen it yet, but essentially what that notation means is, hey, access this inside, the dot goes kind of like inside of it. And in here, all that it means is saying, hey, the phone book, there's going to be a contact, and this contact property will be equals to an empty list. That's all that this is doing, and that's all that matters in this context. And then we have defined a second function. And as you will like learn, all the functions within a class require the first parameter to always be self. And the reason why is because that is how you can access all the other properties in the same class. So it's how you keep everything tied together through that self. So in this case, it's going to be self. That's always going to be the first parameter, the first argument. And then the next one is the full name and phone number. This looks pretty similar, except for that self. And then what's happening is that, here we were doing phonebook.append. In this case, we're just saying self.context.append. And this is where you start seeing the importance of self, right? Because we defined context up here, and because it's part of self, it means that we can use it here. We can say self.context. So it's a nice thing. You can create multiple methods, and they can all use the exact same, the exact same stuff. They can access, stuff from everywhere, because as long as you store it in self, it's kind of like the thing that keeps everything together. It's a common place where you can store variables, for example. So in this case, we access context and we append to it, and then similar to how we had done it, the full name and the phone number. So once again, pretty similar to this. The only difference here is that now it's all part of a class, and we've had to add this funny in it. But this is just how you initialize this class. That's what this means. It only will execute once when the phone book is initialized. So that's the way that works. And now we can actually use it. So in this case, I'm creating my personal phone book. And the way that works is I can just create an instance by using the parentheses. Parentheses means execute. It means, do it. So we are initializing a phone book. And then that instance of the phone book, we're storing it in personal. So this is going to be our personal phone book. And now, and this is where things get fun. Now this function, because it's part of a phone book, it's called a method of that class. And the way that you access methods and anything within that class is through that period notation. So in this case, we're saying personal and then dot add contact. So we're executing this. And then we pass, in this case, the parameters just like we were doing it up here. Add contact, and then the name and the phone number. And that is exactly what we're doing here. And then at the very end, what I'm going to do is I'm going to print personal.contacts. Once again, because these contacts, it's a list, but it is contained within phone book. So, you access personal, and then with dot, you access property. In this case, we're not accessing a method, we're accessing the variable, therefore it's dot contacts. And that's the way it works. So let me go back here. That's our phone book. I'm going to remove this so you can read it slightly better. And now that I've done this, this is looking good. The indentation is correct. I am going to remove this. That's good. Let's clear the history. I guess I have to stop this. Perfect. Alrighty. So now I have my personal, and if I do personal.contacts, you can see my mom. I'll do the same process of adding my dad. So I'm going to say personal dot add contact. And then I'm going to add my dad, and then comma, and then his phone number. Perfect. And now if I use personal.contacts, you can see my dad there. That's perfect. This is pretty much what we had initially. But the nice thing is that we have the class of phone book established. It's kind of like a template, which means that we can use it for many other stuff. So if I want to create a work phone book, I can just say, hey, work is going to be equals to phone book. And then I execute that to create an instance. And now if I do work.contacts, once again, it's using the same template, but it's a different instance, separate. Therefore, work.contacts will start as an empty list. And so then I can do work.add contact. And I can add Lucy, for example. So I work with Lucy. And then I can just add her phone number. Oh yeah, sorry. I should have not added this. There we go. All right. And now if I do work contacts, you can see that Lucy is there. And once again, that hasn't changed anything about my personal.contacts. Personal contacts are still there. And now they're separate. And now, I can just keep on creating multiple phone books out of this class that I've created. And yeah, it's a nice way of creating a template, keeping things separate, keeping things consistent. Yeah. So that is the way that essentially a class works. And with that being mentioned, I think that now I'll give you a few minutes to play around with it. So try to, here are a few examples. If you have any questions, feel free to ask them. Classes can be a bit tricky, and this, sometimes this notation is weird. But yeah, 100%. And once again, if you, and I'm not expecting, especially if you have absolutely zero knowledge of programming at all, I'm not expecting that you would, fully grasp this really quickly. That's completely fine. The only takeaway that I would like you to have out of this is the fact that a class has stuff in it, and that how you access that stuff is through the period. So it can have a method, and that method you can access it by doing dot and then the name of the method, or if it has another property, that is not a function, but that it's more of just a variable. Then you can once again use dot, and then you can access that. That is really all that matters here. Whether you know how to implement it right now or all of that, that's completely fine. Don't stress about it. We won't really be using classes from this point forward. It just will help to explain why things work the way they work in a quick second. So yeah, so once again, let's take a few minutes, and then I can walk you through these examples. And I think there is a question. Is there a shortcut to run only certain lines of code in the main.py file? That's a great question. So the answer is unfortunately no. So if you only want to run certain lines of code, I mean that would be more like a Jupyter notebook thing. The Jupyter notebooks work in that way. I can just quickly pull that up. There's a good example. Yeah, the way that Jupyter notebooks work is a good example of how they work. There's a good example, maybe. Open tab. Yeah, where you have the concept of a cell. So each one is a cell, and you can just run one cell or the next one. So Jupyter notebooks are very much interactive, and this is Python code. It's just a different way of working with it. I would say that it's very nice for doing calculations and stuff like that, where you're doing it in an interactive way. But where Jupyter notebooks are fall short is in running stuff, as entirely, right? You want to run an entire thing, and so the more traditional way is to just run the entire script, which is typically how you do it. Yeah, so 100%. A Jupyter notebook would be more similar to an R notebook, 100%. That is something that you can look into. Once again, I can probably go to Jupyter. I can post this in chat if you want to take a look at it. It's a really nice, nifty tool, especially for if you're doing any work with libraries to I don't know, like do some statistics or machine learning stuff like that. Typically, that is where it really shines, because yeah, you can run things individually or just run a certain cell which contains a certain portion of code. Data science, 100%. There you go. So definitely you want to take a look at Jupyter notebooks, and that would be probably the best way to go in that sense. I think that this is just the more traditional way of doing it with a file, and where this will shine is if you're running stuff on a cluster, for example. Something like a Jupyter notebook is something more interactive, right? You have to be manually running cells and stuff like this, and then looking out the output. It's more for humans. But if you're doing some sort of like processing on a cluster, you'll probably want to write a .py script and execute that in the cluster. So I think that there's different use cases for each one of them. But yes, yeah, Jupyter notebooks be run locally without an internet connection? Yes, that's actually the way it works. So when you create a Jupyter notebook, you actually run it from your command line or your IDE or whatever you're using. And the way it works is that it spins up it creates a server locally. So then you would access it like this local host. In this case, I have is something else. But you would access it like this local host, and it will be something. It will be kind of like a website, but it actually isn't, because it's running locally. So you don't need connection to the internet. Your browser will still be able to resolve it because it's running locally. So it's not a web thing. It's more like an actual local tool. It's just that, yeah, that's the way it works. All right. So in the interest of time, I think that I'll start walking through the examples and try it yourself. So, the first one, we're creating a dictionary, and when we define the dictionary, we're doing personal, and that's phone book, and business, and that's phone book. So that's maybe one way in which you decide to use this, opposed to the way I was doing it through just creating variables out of nowhere. And then something that's happening here is, what happens when you try to print an instance of a phone book. And let's see if I still have it here. Yeah. So if I say print personal, it says, hey, this is a phone book object, and this is the location. And then what this is saying is that, hey, you can change the representation, because that is its string. This is a special method, another special method, but this is what is the string representation of that particular class. And then you can do it like this. So once again, everything needs to have self. That's just the way it is. And then you can return anything, like I'm a phone book or anything like that. By default, it returns kind of like where this phone book is, like what type of instance it is, and then where it's located in memory. But once again, you can overwrite that. You can change it to something else. Just a funny thing, not that it's important or anything like that, just a funny thing to try. But yeah, so classes, as you can see, are once again really cool. They allow you to create kind of like a template for something, and it allows you to add functionality to it by adding methods or properties. And in fact, classes are so cool that everything is pretty much a class. So we've been working with classes without you noticing. When we were defining strings, integers, dictionaries, lists, all of them are classes, and all of them have methods and stuff that you can do with them. So for example, let's here we can start revisiting some of the stuff. So we can go back to a list. So the list can be this, and I'll just delete it. 1 to 5, and it has a method. Once again, when the way you access properties or methods is through that like dot notation. So L dot and then append, and then append allows us to add an element at the very end. So in this case, we can append 6, and if we append 6, I'm just going to be running this stuff proper. Probably makes more sense if I run it from here. Actually, that's already defined. So if I want to append a 6, I can do it right here. And now if I print L, you can see that it's all the way from 1 to 6. Another one of them is extend. Extend allows you to add many elements at the same time. So instead of doing a bunch of appends, you can just do from 7 to 10 all at once. And then if I print L, you can see that now it's going all the way to 10. Another one is pop. So pop allows you to do two things. Well, it removes an element, but at the same time, it returns it. So if I run L pop 5, it's going to return the element at position 5. Position 5, because it starts at 0, the index, right? It will be 6. So if I do L pop 5, we get the 6. And if I print our list, you're going to see that that 6 is missing. It's no longer there. And then we can also insert at position 5 a value of 6. And if we do that, we're just inserting it back. First the position and then the actual value. And if I do it, our list is back to having that 6 between the 5 and the 7. And then if I want to replace an object, there's this other notation that can be used. So this is more like similar to we're accessing item at 0 and we're saying, hey, that's actually going to be equal to 100. So that replaces it. So now if I go back to L, you can see that it's 100 and then 2 all the way to 10. So that's just a few of those items. And then if you want to check out all the methods, there's a function that can help you with that, and it's called help. So if you do help list, so list is a special word. It's the class itself. So if I do this help list, it will show you everything that you can do with it. And right now I'm using the arrows to move up and down. So the ones that start with double underscore, ignore those. Those are special methods. Typically, you wouldn't use those. But then these ones are the ones that you can actually do. So append an object to the end of the list. Clear if you want to remove all items. Copy, count, extend, etc. So all the stuff that you can do. You can sort. You can do count, the occurrences of a certain value, get the index of a certain value. So really, really a lot of stuff that you can do with it. And just by defining a list, you already have access to it. In the same way, though, there are also a lot of things that you can do with a string. str is the class. And so I'll skip over all the special ones. Here we go. So you can do which ones are some? Well, I mean, you can encode, you can say ends with, you can find one that you would use. Yeah, none of these are is decimal, is numeric. That's another stuff. Is upper. Yeah, I mean, replace is yeah. So you can specify a substring and replace it with another one. Yeah, like I mean, to be honest, strings have a bunch. You can split. So if I have something like actually, let's say that maybe you're working with a CSV file, and the name says Fernando, comma Hernandez, and you're like, oh, I wanna I actually want to split this into two variables, right? So name, split it. Okay. We can say actually name dot split, and we're going to split at the comma, and then I can just print name split it. And if I run this, I'll clear this. Now I have Fernando and Hernandez, so now I've separated them, and just like that, like you can do. I think you can also do some stuff like upper to do uppercase. There you go. So now it's all uppercase. You can do lower to do lowercase. You can do a bunch of stuff. So once again, like anytime you're defining anything, a string or whatever, all of those classes, all of those types are actually classes, which means that they have methods and stuff that you can access and you can do with them. So really cool stuff. So there we go. So now you know that. And at this point, I mean, this is something that I introduced very quickly, but there's a few extra operators and stuff that you can do. Like if you want to divide and you want to get the quotient and the remainder as two separate things, you can use a few things like that. And then we've already seen this. What happens if you want to return more than one value, and then how you can set those to separate variables. You can do it. What about split by a delimiter, like hyphen or something? 100%. You can do that. So you would just need to figure out what is that delimiter. So if I do this, that means basically the next line. So you would just have to find what is the right. I think this would be a tab. If it's something different or a space, it would be something like this. But I believe this would be a next line. So it just depends on it depends on the case. You have to see what is the correct form of representing that special character. 100%. You can split by pretty much anything. Yeah, and here are a few also like methods for dictionaries. So you can fetch all the keys and get them as a list. You can do the same with the values. You can do the same with items, which gets an iterable of key value pairs. And you can pop a key. You can add a new key. So these are similar to lists in a way. So quite a few things that you can do, and we can take a few minutes here to just play around with all the different methods. I have a few example here of the things you can do, but feel free to play with dictionaries or lists or anything like that. Like with all the stuff that you can do, it's really really fun stuff. And then we're moving on to logic and some other fun stuff. So yeah, let's take a few minutes and then we can get back to it. Already. So the try to resolve was pretty much what I showcased about using the split function. Something I didn't want to mention this here though is the methods can do different things. So in the case of I mean the particular case of a list, whenever you do something like extend or append, you're affecting the exact same thing. But when you're using a method on something like a string, it returns a new string. So what I mean by that is here, when we were appending, we're saying l dot append, and we assume and we know that this is the list that's getting modified. It's the original L. But in this particular case, it works in a different way. If you have uh, var1 as being a string, when you do dot split, it returns a new string. So it doesn't modify this one. This one remains the same. It's just that it returns a new one. So just this small distinction to make there, which I mean, you can also try out for yourself. And looking at the time here, so the goal is to hopefully finish logic by 12 p.m. and then we can take 1 hour break, and then we just get back at 1, and we can continue with the next section, which is it's we're going to be learning about loops, all the different types of loops, a few extra stuff that I like to throw in, but that's pretty much it. That's what we're going to be looking at when we get back. And then we're going to be jumping into actually the second portion, which is using packages. So we're going to be learning about, and I'll just switch this so that you can see what I'm perfect. And we're going to be switching to using packages. And this is a really nice section because we're going to be learning about matplotlib, pandas, and numpy. NumPy is used a lot. You're going to be using it everywhere, especially if you're doing anything with any sort of like just calculations, computation. Pandas, you might also use it, especially if you're working with CSV files and stuff like that, which is some of the stuff that we're going to be doing. And matplotlib, which is probably the most basic in the very first plotting library that you probably learned about. And so just really basic stuff. We're going to be importing some data, exploring it a bit, and plotting it. So we're not going to be doing anything super fancy, but I just wanted to give you a bit of a preview on what's coming next. And with packages, you're going to see that they simplify so many things a lot, and really we're not going to be writing anything that takes, I don't know, more than 10 lines maybe. So they simplify things a lot. But yeah, so with that being said, let's just quickly get back to where we were before, which is the logic. So we've learned a lot about all the different types and all the things you can do with them, what you can do with lists, what you can do with everything. And this is going to take you, it means that you can create a bunch of stuff. You can already do a bunch of stuff with Python, but now comes a section where, you add that logic to your code. And that is always going to be very important because you have to make decisions, you have to make comparisons, you'll have to, the code will react differently in different ways. And this all comes back to that true and false, which are Booleans and are one of those very basic types that we learned very early on. So let's start by maybe trying to figure out what is true and what isn't true. So I have here an example. So we have a one. Then this is the way that we compare equality. So when we were assigning values to a variable, we were using just a single equals. Now with the double equals, we're saying, hey, is this equal to something else? And in this case, for example, is 1 equal to 1? And this is type of stuff that's probably easier to just run it here. So is 1 equals to 1? And the answer is yes, it will be true. Then is 1 equals to 1, but the second one, as you can see, is a string. And because those are different types, you're going to see that they are not the same. They're not the same. Then we have some comparisons between numbers. Is 10 greater than 5? That is true. Is 4 greater than or equal to? That's what this means, greater than or equal to 4. And the answer is no, because 4 is not going to be greater than or equal to 50. Then we have a comparison between lists. And this is a really important one. So you can see that we have 1, 2, 3, and 1, 2, 3. They're in the same order. They are the same everything. The answer is true. Now, what happens if they are not in the exact same order? Then they are not. So this is another important thing that's important to know. They contain the same elements, but they don't match. Like they're not equal in the sense that the order is different. And for lists, order is important. Therefore, it's not the same. Then we have this fun notation where sometimes you want to know if a number is between different things. So typically, how you would use these. This notation is okay. Maybe you have a variable 1, and you want to see if it's a greater than 0, but it's less than 10. Typically, that's how you use it. But in this case, I'm just hard coding a 5, and 5 is between 0 and 10. Therefore, it will be true. So that's one of those. Then we have how do you say not equal? And the way that not equal works is by using an exclamation mark in front of an equal. So is true not equal to true? And this is where things get confusing, because true is equal to true. So if it's not equal to true, then this will return essentially a false, and that's what it returns, because they are in fact the same. You also have in other programming languages for and or, you're gonna see a double ampersand or a double like double pipes, something like this. I don't know, like true and true, or you're gonna see something like this. In Python, it's just words. So true and true, this will say true. True or false, sorry, true or true will also be true. You can also do not true, and this will mean that this will return false. True and true, we already did it. And then if you want to group comparisons so that it happens in a certain order, you can do that using parentheses. So for example, in this case, false or false will return false. And then true and true will return true. And now we're comparing the result of this and the result of this, which is true or false. And in this case, the entire thing will result in true. And then we have here some nesting. So true or false will be true. Then we have true or false, which will also be true. So this whole thing is true. And then we have true and true will return true. So some of these are just very silly and very complicated, but I hope it gets the point across of what is equal to, what will return a true and what will not return a true. And so now here's where would you use this? Well, typically you would use it in if statements. So here we have an if statement. So we're saying if 10 is less than 100, and then as always, right, this indentation is very important. We can print true. So I can go back here and I can just quickly run this, and we're going to see that this will in fact print true, because 10 is but if we flip this around and we're saying if 10 is greater than 100, in this case nothing will be returned. There we go, nothing was returned because it wasn't true. Then we have the second variation of the if statement, and that's the if else. So we check for a condition, and if that condition is not true, then we say else, and else will be just whatever should happen after that. In this particular case, right, if 20 is less than 10, we're going to print true. But if it isn't, then it's going to print false. So it's either going to go in one, it's either going to run this or it's going to run this. And then we have the final variation, which is the if else. And that is where you start with an if, right? So in this case, I will be equal to 0. And so we're saying, hey, if I is greater than 0, then we're going to print positive. If I is less than 0, we're going to print negative. Otherwise, we're just going to say that it's 0. So that is the way that works. And it's important to mention that, I mean, in this case, there are just going to be 3 situations where this is going to happen. But let's say that this is status, and maybe that will make more sense. And we have a few statuses. We have if status equals we'll look for a 400. We'll look for status equals 500. I don't know that error. The 500 is a server error. Server error. 400 is bad request. There we go. So now we're checking for a status, right? And if it's 400, it will say, hey, there's a bad request, server error. But we can keep chaining elifs. So I can add another elif, and I can say status is equal to 300, for example, actually. 301. I think this is authentication. Print authentication. There we go. And then I can keep chaining elifs as many as I want. So that's the way we use the very simple if and else's. Awesome. And with that, that is pretty much if and else's. So from this point forward, I think, I mean, looking at the time, I could probably go into I could probably talk very quickly about the first type of loop, which is this one. And then with that, we can go and have lunch. So once again, this is just if, else if, it's just logic. And now we're going to move into another thing. So at some point I mentioned, right, sometimes when we create lists, what we want to do them is iterate over each element and do something with that element. In this case, you know, I like to do this example where, you know, we think about what is the output that we want, and then we try to find ways of how to optimize it, how to make it better. So this will be my first implementation. Let's say we have a list of letters, A, B, C, D, and we want to print every letter. Well, this is probably the most basic way that we can do it, right? You know, we can use the print function to print, and then we can say letters, and then using the square brackets, we can access specific elements. And we can access the element at index 0, index 1, index 2, and index 3. And if I run this and I clear all of that, you can see that we get ABCD. It's doing the task. The only issue is that this is not very nice. Like, we can do better. We're copying and pasting this print statement many times. So this is where the for loops come in. This is the first iteration, not necessarily the best iteration, but nonetheless the first version. So a for loop works like this. You say, hey, for I, and I is going to be a variable. It can be anything, to be honest. We can call it number, num, anything we want. In this case, I'm saying I. And I'm saying for I in a list of, you know, numbers. And actually, I need to bring back the letters. I don't need to get rid of that. Perfect. And then for I in this, in 0, 1, 2, 3, we're going to print letters. Letters is pointing back at this. And then the index is a variable. So instead of it, so far we've done it hard-coded. Now we're doing it in a more dynamic way. It's going to be I. So how this is going to look is the first time around. So in the first iteration, the first loop, I is going to take the value of 0. Then it's going to execute, going to go all the way back up. The second time it's going to take the value of 1. It's going to go back up. The next time it's going to take the value of 2, back up, and now it's going to be 3. So every time it's the same code running, but the value of I is changing. And by having that ability, you know, I is changing values, we can change the output, right? So I can rerun this, just clear that. And you can see we get the exact same output that we had before, but now it's better. Now we just have one print statement, and we're iterating over this list. This is the list of indexes. But we can do better. So there's this very fun function called range. And range allows us to create, essentially to generate a list. if you want. So this is a quick example of how range works. I'm just going to use it here. So range 4, and when I run it, this is what I don't like about just running it like this. It returns a range from 0 to 4. But if we do list, now we're forcing this to be a list. It's just we're doing it for the purposes of displaying it, for printing it. So if I force this range to be a list, now we get the list of 0, 1, 2, 3, which is exactly what we're looking for here. And hopefully you can see where we're going with this. Before we do it though, range has a few different ways of using it. So range can also accept 2 parameters. The first one will be the start, and the second one will be the stop. So if I print this, this time it will go from 5, and as I've mentioned in the past, you stop at 1 before your stop. So in this case, 9. So it will be 5, 6, 7, 8, and then you stop at 9. And then there's yet another one, and if you recall from lists, this will be pretty much the same, where you have the first one will be the start, the second one will be the stop, and the third one will be the step. So we're going from 10 all the way to 101, but remember, it's going to stop actually at 1 before that. So we're going from 10 to 100, and it's going to go, the step is 10, therefore it's going to be 10, 20, 30, all the way to 100. When I run that, that's exactly what it is. So that's what range does, and that's how range works. And I mean, if you recall here, we got exactly what we were looking for here. Therefore, we can use this, and I should have not done that. This control insert. And therefore, I can use it here. So I can say range 4. So now we're iterating, or I in range 4. And there you go. We get the exact same ABCD output that we've been looking at. But instead of having, now there's just one thing. There's just range 4. We've simplified and we've optimized this a bit more. But we can do better. There's also a function called len, which stands for length, and it can tell us the length of anything. So this is going to be our final iteration, like our final version of this, where we are first going to count how many letters there are. Instead of having to hard code the 4, it's going to count for us how many items are in this list, and then that is going to be the input for our range. And now our range will generate those numbers from 0 all the way to whatever the length is. And if I run this, we get the exact same output. But now, I mean, no matter what the length of letters is, this will be able to iterate through all of them and print all of them. So that is how the for loop works. It's really nice. And this is only one version. Like you can iterate over things in different ways. This is the more basic one, and maybe a way that you've seen in other programming languages, where what we're iterating over is actually the index, right? So we're iterating over numbers, and those numbers represent indexes, and then we access the index, of that list. But there are other ways in which we can do it. This is another way. In this case, we're saying for letter in letters. So we're not even worrying about the index. We're just saying, hey, these are the letters themselves. Just iterate. Letter is going to be equal to, in the first iteration is going to be A, the second iteration is going to be B, then C, and then D. And if we run this, sure enough, we're going to get the exact same output. So this is just very, very, very simple. And once again, you're iterating over all the items. And then one of the bad things about this form is that sometimes you actually do want to know what index you're on, because it can help you, for example, determine the progress, right? Like if you're on item of index 5 out of 10, you know that you're kind of like halfway there. So it can be sometimes useful to know what index you're on. And in order to do that, you can use enumerate. So enumerate is a nice function that allows you to, and let me just copy it over. I'll run it here. There we go. Enumerate letters. So we're going to enumerate, and when we enumerate, what we get is, and actually I have to cast it to a list so that we can see. This is just for printing purposes when it's, there we go. That's what it looks like. So it's a list where each element is a tuple. And if you recall, a tuple is basically just a list that can't be changed. So you can't change anything around. And the first one is going to be the index, and the second one is going to be the actual value. And then through the magic of tuple unpacking, which is something that we've already learned, similar to how you know, if you do something like this, equals 0, comma a, the 0 will end up in the I, and the A will end up in the letter. It's the same as doing this. Sorry about this, like that. So just like we've seen this in the past, you can do the exact same thing. So we're doing it. We're doing it the exact same way, but it's all within the same place. So we enumerate first, and then we iterate over each one of them, and each one of them will look like this. And because we're saying I comma letter, it's going to unpack it such that 0 will end up in I and A will end up in letter. And then the same happens for all the other iterations. And then if I print I letter, in this case, it's just going to look like this 0 A, B, C, D, but I can also disregard the I and just do this. So this is a nice way of, through it, using the enumerate, you can get both the index and you can also get the actual item that you're iterating over. And that's pretty much loops. So I think we have here 10 minutes, and what I'll say is let's take these 10 minutes to just practice some of the stuff that we've seen. And once again, when we get back at 1 p.m., we'll get back to discuss while loops and a few extra. This is not really important, but I like to mention it just so you know it's there if you ever need it. And then we'll jump into using packages and importing data, working with numbers and plotting them and stuff like that. So I think that is pretty much it for now. So we're now in the second part of the workshop. But yeah, so in case there's anyone who still isn't here, I think I'll first just do a quick recap of everything we've seen this morning, which is a lot. We started with, just the data types and how computers interpret, how to tell a computer how to interpret, whatever we wanted to store or to use. Then we talked about variables, how they work. We talked about the print function, lists, dictionaries, all the things you can do with those. Then functions, local variables versus global variables, and what you can modify and what you can't modify from a function. Then we discussed classes and how they may be used. And then we learned that pretty much everything is classes, are classes. And we learned about some of the methods that lists have, that dictionaries have, and that also strings have. And then finally, at the very end of the morning, we were learning about logic, what is true, what is false, how you can compare things, equality, greater than, less than, greater than, or equal to. And we learned about the if else, elif, which the elif is always a weird one. We learned about loops, and we learned about how to do the most complicated and not very efficient way of accomplishing it, and then how you can improve upon that in a few different variations using the length and I for the index, just iterating over the items themselves, or using enumerate to get the best of both worlds and be able to have the index, but also the item or the element itself. So, yeah, so that's I think where we left off. And the only thing we have missing, as I mentioned before we left for lunch, are the while loops, which we'll be learning about in a sec, and a few extra things that I wanted to mention. And then from that point forward, we can move on to learning about some packages that you may probably use. There's some of the, those basic packages that you tend to use, especially if you're working with data. And then hopefully that can give you some of that foundation so that there you can go and use more complex packages or more specific packages for other uses, and then do whatever it is that you want to do. Like, I think that's a very nice thing about Python. It's a very just broad language in the sense that you can do so much with it. There are so many packages to do so many things. So yeah, it's a very versatile language, and that's a really nice thing and really powerful thing, as well as all the community behind it. So really cool. So with all of that being said, and hoping that everyone is back and ready to go, let's just discuss while loops and how they work, and when you may want to use them. So when we learned about for loops, we said that basically you're iterating over something, and you're iterating over something that has a defined length, whether that's a list, or, well, yeah, typically a list, so or a range, but it has a defined beginning and a defined end. A while loop doesn't have a defined end, because it's a conditional loop, which means that while a condition is true, we'll keep going around this loop and doing it over and over and over again. Here is the most basic while loop that I can probably think of, but I would recommend that you don't run it. The reason why is because what this is saying while and then true, and true is our condition. It can be anything. You can make it, and here's where the logic comes in, and what we've learned so far, comparisons and all that. But in this case, I'm just inserting true, hard coding it, which means that it will always be true because this condition is never going to change. In while true, then we're going to be printing still running. And if you were to actually run this will run forever, because the program that has no way of exiting this loop. It will keep running forever. And forever is probably not great for what we're trying to do. So let's add some more logic so that the loop can stop at some point. And this is a very silly but a very simple example. So maybe we globally define a variable called num, and this num variable will be 0. So now we go into the while loop, and what we say is, hey, while num is less than 1000, do whatever is in it. Once again, as we mentioned, for pretty much everything, indentation is important whenever you see stuff that uses colons. If you're using parentheses or brackets, square brackets, curly brackets, whatever, typically you're fine with getting, you don't have to worry about indentation. But in situations where you're just using a colon, then indentation is very important. So in this way, I'm doing this notation. But what this means is the exact same as saying num is equal to num plus 1. Now notice two things. Remember, in functions, you couldn't modify a global variable from within a function, or redefine it, I should say. In this case, it's a while loop, and it works in a different way. So here you can in fact modify this variable. It would be a different situation if this while loop was within a function. Then in that case, it wouldn't be the case. But as long as the while loop is in the same place where the variable is defined, you're good to go. And so once again, this means, hey, the number, replace it with whatever the number currently is, but add 1 to it. So it means that at each iteration, the number will be increasing. So the first time it will be 0 because that's the initial value. Then we add 1, so now it's 1, 2, and it will keep going through that while loop until this condition is no longer met. And at that point, once the number becomes 1000, then this will no longer be, and then we will keep going to the next line of execution. So once again, we're kind of just going in order, right? Like it's just that this while loop is preventing the instructions from going to the next line, because while that condition is true, you're going to be stuck in that loop. And then eventually, if that condition is no longer met, then you exit. And then we can print the number, and the expected value for it would be 1000, because it's only at that point when this breaks for the first time. So that's the way that while loop works. Now, there's another thing that is important to mention, and this applies to both while loops and for loops, and that is the concept of break and continue. So these are two special words that you can use to break out of a loop or to skip a certain iteration. So here's a quick example where we're doing for I in range 10. So this range 10 is going from 0 to 9. And what we're saying here is, and we have nest things, right? So we have the for loop. There's the indentation for the stuff inside the for loop. But then we have an if, and that if requires another indentation. So that's why the break has double indentation, essentially. So in this case, the loop will like consists of all of this, but in this is the main line that will be running. So the first time around, I is equals to 0. If I is equal to 5, which in this iteration it won't be, so then it just skips over, and then it takes us back to the top. So this time the value of I will be 1, and 1 is not equal to 5, so then we go all the way back up. And then we keep doing that until I will be equal to 5. And at this point, we have this condition. If I is equal to 5, break. And what break will do is that it will exit out of this for loop. And therefore, the next line will actually execute. And this is just going to print at which point, what was the value of I when you exited out of it. And the expectation should be that value will be 5, because it's only once it reaches 5 that break actually kicks in. If there was no break, then you would keep going all the way up to 9, thanks to the range. But in this particular case, that's not the case, because at 5 we break. So that's the way that break works. So break is just like exit out of this whole thing. Sometimes it can be useful if maybe you're iterating, or maybe you're using a while loop, and you're searching for something, or you're doing some sort of operation or some sort of algorithm where, the moment you find something, then retrieve it, or something like that. Those would be situations where you would find that break very useful, because it's like you don't want to keep you want to keep iterating until you find whatever it is that you want to find, and at that point you exit. So that's how the break works. And then we have continue, and continue is different. Continue means go back to the for loop and continue, with the next iteration, essentially. And the way this looks, here's a quick example. So the idea is that first, once again, we're iterating over a range from 0 to 9. And if I is equal to 5, we're going to say continue. But if this doesn't execute, then print I will happen. So what's going to happen is that first time around, I is going to be 0. This is not going to execute because 0 is not equal to 5. And then we're going to print 0, and then we're going to print 1, go back to the top, print 2, print 3, print 4. And then when I is equal to 5, this will actually allow us to go into the next line, which is continue. And so continue will say, hey, let's go back up and just continue with the next one. So now we'll go back here, and I will be 6. But if you notice, print never ran because continue prevented it from happening. And therefore, we should end up with every number being printed except for the number 5. So let me clear this. Let me stop this, clear, and let's rerun. Oh, and apologies. When I pasted this, the indentation didn't work. And I mean, this is what I'm talking about exactly when I mentioned that indentation is very important. This is very important. If this is also very important because this continue is not inside this if. Now it's inside the if. So a few things to keep in mind. So let's run this again. And oh, sorry. Once again, indentation is very important. Print is right now it's outside of the loop, so it will only trigger once at the very end of the loop. But we actually want it to happen at the end of each iteration of this for loop. And so if I run this again, once again, we're going to be printing every I except for 5. And there we go. So 0 is printed, 1, 2, 3, 4. But when we get to 5, we hit the continue. So continue takes us to the top, and we just continue and skip it. So this is, where would you use continue? Maybe you're calculating something, and you can put a condition where if a certain calculation returns not a number or something like that, right? Like where that calculation didn't work, but it doesn't matter. You just want to keep going and keep iterating over the rest of the numbers. Then that's a situation where you can use continue, where you can just continue to the next thing. So that is how those two conditions work, along with while loops. And I think here we can take a few minutes to try it yourself. So feel free to play. Here's a nice example. Let's see if you can figure it out. And feel free to play with some while loops. Be very careful with this condition, because if it never changes, your loop will never stop. So let's take a few minutes, and then we'll be back to these last few things that I just like to add, just so you know them. But yeah. All right. So I think I'll just cover the example, try it yourself from this section. So it's saying create a list of integers, add a string somewhere in the middle of the list, and then iterate over the objects and print only the integers by skipping strings using continue. And then I added some hints if you want to test it out. So here's one implementation of it. You can see that I'm using a for loop, and I don't care about the index, so I'm just iterating over the items themselves. Here's my list, and you can see that we have one string. And then I'm using if, right? I'm putting together the conditionals with the loops, and then I'm checking if the type of whatever item it is that I'm using, if it's not equal to int, and int is for integer, then we're going to continue. And as we saw in the example that we did previously, this will send you back up, and it will not let any other lines below execute. In this case, that line is the line that actually prints the item. So as you can see, the output that we get is the expected output, where it goes all the way to 9. I think that in this case, I was hinting at using string instead. So the idea here was saying, hey, if the type is equal to a str, which is for string, then continue. This will give you the exact same result. I'll just show you what, maybe something you would want to consider. It's a toy example, so it doesn't matter too much, but you can see you get the exact same result. I think the only reason why I did is, let's say that you also you have a true. With this implementation, we are only continuing only if the type of the item is equal to a string. And in this case, Boolean is not a string. Therefore, when I hit run, true will be still printed. This line will still execute. So that is the only reason why I used not an integer, because it means that anything that's not an integer will be, there you go, will not be printed. So I mean, it's okay. Like it's a toy example. I think that's one of the nice things about code is there's no single perfect implementation. It's all about what are the conditions that you need to meet, that your code needs to meet. And if you're able to do it, and ideally in an efficient way, then that's all that matters. But yeah, already. So that is pretty much everything. Like this, everything that we've seen today is going to take you pretty far. I mean, yeah, it's pretty much most of what you need to know. There are, from here on, there's things about packages which we're going to be learning soon, and um, file structure, stuff like that, dependencies. But in terms of the actual coding, stuff that you need to know, that's pretty much it. From here, I just wanted to quickly talk about a few extra things that I find really useful. So the first one is Lambda functions. I think, and you're going to see why they are useful in a second. So this is my example of maybe you have a function that does some sort of calculation, right? So it takes a value x, and then it calculates x to, this means to the power, so x to the power of x, and then it divides it by x. That's what it does, and then it returns y. And so then I can call my function, and I'm going to call it with 4. So 4 to the power of 4 divided by 4 is 16. And that's what we get back. Perfect. What a Lambda function allows us to do is to create essentially a one-line function. And this can be really nice. Well, I mean, in this particular situation, it's just going to clean up things. Instead of having multiple lines and doing all of this, you just have a one-liner that's a bit cleaner. So you define it almost as if it was a variable, but what it actually is equal to lambda, and then you determine what are the arguments. So if this was a function that took x and y, you can do it like this. So you can add as many arguments as you want, but in this case it's just x, and then you use the colon, and then in the same line you put whatever you want it to do. In this case, once again, x to the power of x divided by x. And you can see that if we run it, we get the exact same output. So cool. You just saved a few lines. No big deal. But where it comes useful is when you mix it with other stuff. So before we put it together, I'll just explain map. So the map function is a really useful one. So sometimes you'll have a list, something like this. And let's say that you want to get the square of each of those items. This is one way of doing it. So this is using a for loop. Once again, programming, there's many ways of doing things, and none of them is all of them are valid. So we have two lists. We have our original list, and then the list where everything is squared. And then we're going to iterate for number in L squared dot append number to the power of 2. And then we're just going to print the list at the very end. That's all that we're doing. If I run it, you can see that we get 1, 4, 9, 16, 25, exactly what you would expect to be the square root of all of these. This is great. This is nice. But there's a way in which you can do it in a I would say it's just a more elegant way, and that is using the map function. So the map function works like this. First, you need to define a function that does your transformation. And in this case, it's x, and it will return x to the power of 2. That's our function. And then map, you just say, hey, I want to map this list, and the transformation that you have to apply to each item in this list is this function. And so it's going to iterate over each item in the list, and then it will transform it using whatever function you give it. And then you end up in this case with L squared, and then I'm by default it's a map object thing, so I'm just casting it to a list just so that it can be nicely represented in the print. That's the only reason why I'm doing it like that. So I can run this, and you can see that we get the exact same output that we had last time. The only difference is that map. Now we don't need any for loops. Like this is happening just within the map function. But we can take it a step further, and this is where Lambda comes in. So we can literally do all of this in pretty much a single line, just like this. So remember what Lambda, the first argument is our function. But we don't need to define a function and use multiple lines of code. We literally can use the Lambda function and say, hey, yes, the Lambda function accepts one parameter, x, and then it returns x to the power of 2. And then the second argument of the map function is the actual iterable. So this is all we need to do. And now, just like that, we can map it to L squared. And then, once again, I'm printing that. So I can stop this, I can clear this, I can run it. Same exact output. It's just been reduced to one line. And it's, I mean, I would argue that it's extremely readable in the way that, you're mapping this list to this list by applying this transformation to each item. So really cool. I use map whenever, like, I don't know, I really like map, and I found it really helpful. So I like to talk about it. And that is pretty much it, to be honest. There are other similar functions to map. There's filter. This one's also super useful. Whenever you want to filter items, you want to find maybe especially when it's more complicated cases where, maybe it's a list of dictionaries and you're trying to find a specific value or something like that. And you can also sort, and they all work in a similar way to map. Of course, you can always look at help and then map, and you can learn about how it works. So you can see that it accepts a function and then some iterables. And the same you can do for filter and sorted, or you can also Google it and you can see how it works, and you can see some examples. And that is pretty much it. For all of the content that I wanted to showcase in regards to the basics of Python, and broadly speaking, really programming languages, you're going to find that a lot of this is transferable to other programming languages. So that is pretty much it for that section. And now we can shift our focus to discussing packages and doing some maybe some more useful stuff, or leveraging packages to do really cool stuff. So I'll go ahead and stop this, clear my screen, clear this, and now we can switch gears to talking about using packages. So packages is really where all power of Python is, because there's really smart people out there that in a really great community that are creating packages to do pretty much anything using Python, which is really awesome. And they essentially, these packages simplify complex tasks and makes just the development process way faster and way easier. And there are two types of packages. There's internal packages and external packages. So an internal package, it would be something that you don't need to import. So for example, I believe math would be one of them, if I'm not mistaken. Yeah, so there's a few. There's random, for example, to be able to generate random numbers and stuff like that. OS to access operating system related stuff. Like there's datetime to work with dates and stuff like that. And these are all internal packages. In fact, you can see JSON, OS, all of these are internal packages. You don't need to install them in any way. Like they're just included as part of the Python installation. It's just that by default, all of the functions or classes that are in that package are not available, just because they would clutter a lot your code. So it's just like you need to import them explicitly to be able to have access to them. And then there are external packages, and these would be the type of packages that would be developed by the community, and then they are made available through something like the Python package index. This is typically where you install stuff from. And the way it works is like this. Python has a package manager, which is pip. And through pip, you can install packages. And typically, this is the command: pip install and then the name of the package. So a good example would be NumPy. NumPy is the first one that we're going to be working with. And And I believe it should be this. There we go. And so you can see that it tells you how to install it. It's just pip install numpy. That's the way that it's just going to install it. Now, it is important to mention that if you just run this on your command line, it will install this globally to your general Python, to your overall Python installation. And this may not be what you want because, sometimes you're going to be working with different, you're going to be creating multiple projects. And ideally, you want all the dependencies to remain within that project and all the versions to be very specific. Because it could be that, I don't know, in maybe NumPy is not a great example for that, but maybe another package like scikit-learn, which is for machine learning, there may be a new function or a new algorithm that's available in one version that's not available in the other. And if one project, you use it using one version, but you install that globally, and then for another project, like it can break another project, right? Like different projects should have their own separate dependencies to avoid any compatibility issues between package versions or even packages, right? Like imagine you're just installing all of this bunch of packages that you use from all your projects, right? Like, and there's no separation of which projects actually use which packages. So all of that can get a bit messy whenever you're using a bunch of packages, and that's why the best practice is to separate and keep dependencies with each project. And the way that you do this, I mean, there's a few different ways. I would say that the traditional way of doing it is to create a requirements.txt file. I won't go into the details, but you can look it up online. But there are also nice projects that have improved the experience. And one of them is the one that is used by Replit, and that is Poetry. So if you look for Poetry Python, you can learn about how it works. It's a dependency management tool. And yeah, and you can see how it works and how to get started with it. But all right, and that's, as I mentioned, like these two files are exactly for that, and that's what they're doing. These are for package. In one of them, it's specifying the dependencies. So our dependencies are Python, Pandas, Matplotlib, specifies which versions, and then the lock is just the actual, like, yeah, like this defines, here it means that it needs to be a version like 1 point something. It can't be 2. It has to be 1 point something. But Poetry Lock is the one that tells you exactly which version it installed. So it might not be 1.4. Maybe in the Poetry Lock, it's actually 1.5 point something else. So yeah, so this just defines the kind of like the guidelines, but this defines the exact version. And that's what those two files are doing there. So once again, highly recommended that you do that you create different environments for each package that you work on. You can use Poetry. If you're using something like Anaconda, then you can do it with the Conda environments. Like, but just thought I would throw that out there. Now, a really nice thing about Replit is that because it's so, it makes everything, simplifies it so much. It's really nice. We don't have to worry about installing any packages. The moment it recognizes that you're importing an external package, it will automatically add it to the dependencies and install it. So it makes things really, really easy. So we won't have to do any of that today, but just wanted to mention it so you knew it for the future. So let's start by talking about importing packages. So the way you import them typically is literally just import space and the name of that package. This is an example for NumPy. Now, typically, developers are lazy and we don't want to type NumPy every time we want to use one of its functions or classes. So typically, we just say, hey, import NumPy as NP. And now that shortens NumPy to just NP. You can also just import as a specific component. Maybe from NumPy, we only want to use random. And in that case, we can say from NumPy, import random. Or we can even chain it with the as something and say import random as nprand, for example. Or we can use the period notation too. Once again, period notation means there, it's kind of like it's something within something within something. That's the way that it works. So here's another example. It's the exact same as this. And we can also, well, I mean, this is the exact same thing. From matplotlib, for example, we'll be using this later. Import pyplot, and then we can change it to as plt, just to simplify things. So a few examples on how you can import stuff. Whichever way is fine. And here's a question about, are some packages so large it would be advantageous to only import one component, like random from NumPy? Yes, like, I mean, I think that it's something you would have to test out and see if there's a difference in performance from importing the whole thing versus just importing. Sometimes there might not be a big difference, but ideally, yeah, like you should try to just import whatever it is that you're trying to use. NumPy, for example, can include a bunch of stuff, but we're just going to be using this. Therefore, why importing the entire thing? It also simplifies things a bit more, because instead of having, if I do this and I want to access random, then I would have to type np.random. And then whatever I want to use. Whereas if you import it like this, then you can just say np_rand and then dot whatever it is that you want to use. So it just, I think that it's just more about, yes, there's something to be said about only importing a certain section of the entire package, but I think that in the end, what becomes more important is how convenient it is to use it in your code, and how easy to understand it is too, so that you know exactly what you're using. np. something, I'm using NumPy. PLT, I'm using matplotlib. That's really what I would say is the most important thing. So with that being said, let's get started with NumPy and let's get started with arrays. So one of the limitations of just using plain Python is, what happens when you get to much more complex computations, multi-dimensional arrays and stuff like that, and making those calculations, dot products, all of that stuff. Plain Python is not meant to be used for it. So that is a situation where NumPy comes in very handy. Now the other very useful thing about NumPy is that under the hood, it actually uses some, if I'm not mistaken, some C code, which it's faster than Python. So you're going to notice certain operations are way faster if you do them with NumPy. Once again, this is just when you're getting to really all the like numerical calculations and stuff like that. If you're doing really basic stuff, there's no difference. But if you're doing something more fancy, NumPy is the way to go. So here we have a quick example in which we're generating two arrays. So we're importing NumPy as NP, and NP, they have a few methods available to us. We have, for example, .zeros, and zeros is, well, I mean, it allows us to generate some zeros essentially. And then the first thing that we get to specify is the type, the shape of it. In this case, it will be 8 by 8, and then there are some arguments that you can pass, such as what is going to be the data type. In NumPy, it gets way more complex. You can specify int 32, int 16, whatever, float 32, float 16. You can get very complex, very specific about what type you're trying to use. Stuff that typically with plain Python is a bit more simple. You have int, you have float, and that's pretty much it. Whereas here you can specify the size. So it's a bit more specific like that. So I'm just going to run this, and then I'll show you. The other nice thing is that when you print it, well, yeah, you can see the different types, but more importantly, I wanted to show you the actual arrays, what they look like. There we go. So this is the nice thing too about now these arrays are two-dimensional, as you can see by the shape 8x8. But you can see that when you print them, they represent them in a nice way, in a very visual way. So I like that. Like it's very easy to understand what's happening, and you can see that depending on the data type. The first one is an integer, so it just displays the 0 itself. But the second one is a float 32, therefore it does include the period. So really important. Don't get confused NumPy arrays with Python lists because they're different. NumPy arrays can only contain numbers. As we've learned, a Python list can contain anything. So there's trade-offs, I guess, depending on what, it's all depending on your application, right? Like, once again, if you're working with numbers, matrices, dot products, stuff like that, NumPy is the way to go. So that is a very, very, just two examples of completely empty NumPy arrays. So there are some really, really cool. I mean, I already discussed, calculating the dot product, and here's a quick example. Of course, all of this, it's the best way to learn it is to actually go to the documentation. I've actually linked the documentation up here. So if you want to learn about all the stuff you have available in NumPy, you can click on that. You can see there's a getting started, there's a user guide. And you can learn about pretty much anything if I move this around. Well, I mean, there's the basics, the different properties. So shape, I've already described that, but there's also size, and this will give you the number of elements in the array. The type, which I already showcased, it tells you what's the data type. You can do ranges, you can reshape, you can pretty much get any. This is how you can transform a Python list and transform it into a NumPy array. That's something that you can do. Yeah, and then there's just a bunch of, you can create an empty array, you can create pretty much, like linear space, and this will give you a more complex, like for example with Python you could generate a range, but that range is a range of integers. In this case with linear space you can go from 0 to 2, and you can determine how many items you wanted to have. So once again, like different use cases and different situations in which you would want to use one or the other. But yeah, so here's another example, right? We generate two arrays, and I'll just make sure I print this two arrays, print array1, R2. I can run this again. I can hide it. This didn't print as nicely. I can probably do it better. There we go. That'll be better. All right, there we go. So it's two very simple 2D arrays, and then the dot product, and this is how you can do it. So just some really quick stuff for it. Not that we're going to be doing right now any fancy stuff with it. Another really useful feature that NumPy has is the fact that you can save an array, and it's going to save it in this funny format called NPY. So what that allows you to do is that you can perform some calculations, and then you store that array and you store it in memory, right? Like as an actual file. And then in a later file or something like that, or at another point in time, you can do np load, and then you can load that array. So this is really useful, for example, in machine learning, where you want to save the weights of of your neural net or something like that, and you want to store them so that you can load them again in the future to actually perform predictions or stuff like that. So real cool stuff that you can do with NumPy. I don't want to dive into the details because once again, it depends really on what you want to do with and many times, NumPy ends up being part of something else. So if you're working with scikit-learn, if you're working with TensorFlow, if you're working with other like machine learning libraries, Keras, PyTorch, et cetera, in the end, NumPy arrays are probably going to be a part of it. And so, but you won't, you don't necessarily will be the one programming and coding all of this stuff. Like you'll try to use whatever those packages make available. So just thought I would mention and showcase a few things of NumPy. Then now let's say we're trying to work with tables, and now I'll switch gears to a more let's say we're trying to work with CSV files, stuff like that. In plain Python, maybe this is the way that you would want to work with a table. This is something made up. It's weekly stock price, and each row represents a week. So we have week 1, week 2, and each column represents a day of the week, starting from Monday going all the way to Sunday. And this we're gonna say it's dollars. Maybe this is how you want to work with it, but it's in plain Python. This would be really hard to work with. Accessing items, doing stuff. It's not very convenient. So, anytime you run into something that seems too complicated, there's probably a package that does it for you and that will simplify your life. And Pandas is a really popular and really nice package to work with tables, and it's really powerful. So the magic of it is it's a data frame, and you can see data frame is if you look at the casing, right, capital D, capital F, this is camel case, but you can see that we're importing, and that's how you know that this is a class. As this is what I was talking about, the conventions, right? Like stuff like functions are in lowercase. In this case, nothing is using snake case because nothing requires the spaces, but this is how you know. That's the nice thing about conventions. You just by looking at it, you can know if it's a class or a method or something like that. And then you can see that you can give it, in this case, what I'm passing is a dictionary, and that dictionary is representing, in this case, because of the way you can define data frames in many different ways, but this is one way in which you can do it, which your key becomes the column title, and then you pass as a string, like as a list, all the values. So this is kind of like the same table that I had previously, but it's now kind of sideways. And I've added some more weeks. Instead of 2 weeks, I've added 4 weeks. And then I can also specify what should be the index. So week 1 will be all these values. Week 2 will be the second values, third values, and fourth. So that is the data frame that I'm generating. I'll stop this, I'll clear, I'll run. And there we go. All right. So now we have our data frame, and we've stored it in a variable called df. And if I just do df right now, it's going to print it. And once again, like this library makes it really nice to visualize that table, right? So you can immediately see that all the days were correctly used as the columns, and the index was also done correctly. If we hadn't specified any of this, they would probably be just numbers, and yeah. But this, for this particular situation, it makes sense for it to be like this. So that's great. We have it. One of the nice things that you can immediately do is use the .describe method. So this data frame, it's a class, and one of its methods is describe. And describe will just give us some really quick statistics about it, especially if it's numbers. One nice thing about Pandas is that it can also work with strings or dates. So we're not limited to just numbers. In this case, I'm only using numbers, but we're not limited to it. So if I do .describe and the types are numbers, it will get some statistics. Actually, I think I can do D types or D types. There we go, D types. You can see that column Monday is an integer 64. So by default, it will try to guess what is the type of each column. So that's what it said it is. But yeah, so now if I go back and I do dot describe, and this is a method like d types. It's because it's a property, you don't need to use the parentheses. But in the case of describe, it is a method, therefore you need to run it with the parentheses. If I do dot describe, you can see that it's getting the count. So all of them have 4 values, so nothing crazy there. Then you can see the mean of each day, standard deviation, the minimum, maximum, and the percentiles. So really quick way of getting those stats, really cool stuff. And you can see this 3 dots. That's just because there's not enough space to represent all of it. But yeah, so this is it's a really nice library to work with numbers. We're going to be learning soon about how we can import stuff. But before we get there, some important stuff here is how do we access access specific elements in the and I want to see if I can, because I feel like I'm just getting to, let's stop this, let's clear, let's run again. All right, awesome. So I'll just print the DF so you can see it. And now what we're going to be doing is we're going to actually access the individual items. For example, let's see, I want to pull this too. What would be one way of doing it? So that is when we get into being able to select stuff. And for that, there are 2 ways in which we can do it. There's iLock and lock. So we can locate based on the names of the column in the index, or we can do it just by index, or meaning just by numbers. So here's an example for iLock. So in this case, I can just copy this over. Shift insert, and I'm going to use df.ilock. All right, so this is a very funny thing. So if you remember from lists, we're still using square brackets, but this time we're using this very fun notation where there's, we're using comma separated stuff. And what that means is that we're accessing row and column, if I'm mistaken. Row, column, row, column, if I'm not mistaken. So in this particular case, if I run this, we're going to go into row 0, 1, 2. So this is week 3. And then column is 1, and everything's 0 index, so it's 0, 1. So what we're accessing right now is Tuesday from week 3, and that's why we get a 4 back. So that is one way in which you can access a particular value. But you can also use ranges. And this is something that we learned early on with lists. We can use pretty much the exact same notation. So df, paste this. So this time, let's see that we want to row. So again, a row will be from row 1 to row 3. So this is 0, this is 1, this is 2, this is 3. If you recall, you stop 1 before the actual number, right? So in this case, it will just be 1 and 2. It won't include 3. So it will be week 1 and week 3. And then for the columns, we've selected everything. So essentially what we should end up with is everything that's highlighted. All days of the week, but just week 2 and week 3. And if I run that, that is exactly what we get. So we've gotten kind of like a sub table out of the whole table. This can be useful if you want to run analysis on only certain weeks or something like that. And now we can switch over to the more readable version or the more human way of doing it, which is using lock. So this time, instead of using indexes and numbers, we actually use the names of the names of those columns and rows. And here's a good example. So now this means that we want to locate week 3 and then Wednesday. So I'll be week 3 and Wednesday, which means that the value should be a 2. And in pretty much the same way, we can also do it with ranges. Now, ranges work slightly different in this case. As I mentioned, when we're working with indexes, you stop at one before whatever you specify. But in this case, because we're actually providing keys, it actually does include them. So in this case, week 3 and week 4 will include, in fact, week 3 and week 4, and Friday to Sunday will include Friday and Sunday values, which means that we should end up with these values and these values. If I run that, that is exactly what we get. So we get 763 and 876. And I think there's a quick question here. For data frames, do you need to name the columns and rows, or are there default names that would work if you haven't? Yeah, 100%. I could have removed this, and I can showcase that in a second. I'll just do this example, the example, but then I'll remove it. And yes, 100%. I can show that in a second. So the final thing that I wanted to showcase, which is another really powerful thing of pandas, is that when you're selecting stuff, you can use conditions. So here's how that works. We'll have to unpack this little by little. So let's first, what I want to do. Let's first use this df, and then we're specifying the square brackets mon. By doing this, we're saying, hey, from the data frame, only select Monday. So then we only get Monday as a column. Simple enough. Now, another thing that we can do is we can do conditionals, and we can say, hey, show me the column Monday, but only the values that are higher than 4. If I run this here, we're going to see what that looks like. So I'm selecting once again the Monday column, but instead of showing me 2, 4, 5, 6, it's going to show me a true or false of what values are true and what values don't meet that condition. So if I run this, what we get is false, false, true, true. And that is because 2 is not higher than 4. 4 is not higher than 4 because it's equal. And then 5 and 6 are higher than 4. Therefore, those 2 return true. So this is really cool. So then it means that by knowing this, we can locate all the rows where the values from Monday are higher than 4, and then retrieve all the columns. And what that is going to look like, if I copy and paste this over here. So once again, we know that the only rows that are true for, that where the Monday value is higher than 4 is week 3 and week 4. And we're selecting only those rows, and then we're selecting all columns. Therefore, what we're going to end up with is week 3 and week 4. And if I hit enter, that is exactly what we end up with. And I mean, if this wasn't the case, right? If week 2 was higher than 4, and this was another value less than 4, then we would end up with week 2 and week 4. So it's a really nice way of conditionally selecting rows or values in a table really quickly. So really powerful thing about the data frames. And before I move to the next section, I'll get back to that question about what happens if you don't specify that. So for the index, if I don't specify it, I'll stop this and clear it. What's going to happen is that, there we go. The data frame will just have for the index 1, 2, 3, 0, 1, 2, 3. And if I don't want to specify, I believe there's a way of doing it like this. So I'll just have to get rid of these items. It's good. Let's see if this works. Oh, I need to close this. There we go. Yeah. So this is what happens if you don't specify, so this is a list of lists. And this is what happens in that particular case. First of all, it's interpreted in a different way. So it's interpreted vertically. Um, and the second thing that changes is that, yeah, those column names don't exist as well as the index names. It's just like this. So at this point, like you wouldn't be able to use this form, which yeah. Once again, like you can do it, but and then I think once you've defined the data frame, there's a way of renaming columns and stuff like that. But yeah, so good question. But yes, the defaults is just put numbers to them. That's default. Perfect. So, with that being a quick introduction to the pandas data frames, I mean, we're not going to be doing, we're going to be selecting some stuff, but we're not going to get too fancy about this. Let's jump over to maybe, this is what I really wanted to build up today. As I mentioned at the very, very beginning, we have a CSV here. And what this CSV contains is information about a very basic an introductory classification problem where you have three types of iris plants. So there's three species, and then you're trying to figure out if just based on the sepal width and length and the petal width and length, you can classify the plants. And so if we take a look at the data, this is what it looks like. So first we have the sepal length, then we have the sepal width, petal length, petal width, and then we have the actual label. What should be the right thing? So we have some iris setosa, versicolor, and virginica. So our data set is very short. It's just like 150 samples. And those are the measurements from all those plants. So then the whole goal is trying to classify just based off of those four attributes that you have access to, those four features. And so what we're going to do and what we can do here is that we can actually read a CSV. It's very quickly with pandas. So I'm just going to go and say that our data frame df is going to be equal to pandas dot read CSV, and then we're specifying the name of CSV. Important thing to mention here, if you notice, main.py and data.csv are at the same location. Therefore, the relative path from one to the other is the exact same place. That's why I'm able to do this. If data.csv was inside content, for example, then I would have to say content, because content is content. Because content is at the same level as main.py, and then / data.csv. So it just needs to be a relative path. Or it can be a global path. If you have it somewhere else in a different place, you can put the full path to it. But yeah, so that's how that works. So let's stop this, clear everything, and let's run it. And oh, I need to move it back. There we go. Now it's back. Stop, clear, and run. All right. So if I do df, it's going to show us a small preview. You can't display the whole thing because it would take up all of the space. But there you go. This is more or less what it looks like. So, and this is actually a good example, right? We have column names. By default, pandas grabs the first row and it uses it as the columns. You can specify it through an optional argument to not do that. And then you have all the rows are just indexed based on numbers. But yeah, so we can quickly see that just like that, we imported a CSV, and now we can actually do stuff with it. So we can see, for example, that we have, oh, there's another question. Hypothetically, if something like your third row was the headers, can you easily have it skip a couple rows? I think the answer is yes. Let me see what pandas read CSV tells us. According to the documentation, yeah, header by default, it's going to infer. But if we go to the specific row numbers containing column labels and marking the start of the data, zero index. So yes, 100%. If you say header equals, if the third row, then in that case you say header equals 2, and then it will go down because it's zero index. It will go down to that third row, and that will become the headers, and then the rest of the data. So 100% you can do it. But yeah, there you go. Like there's so much stuff that you can specify. Fair enough. Yes. Yeah, CSV files, like Excel files, stuff like that, it's hard to work with because there's no constant format. But yeah, so this is what it looks like. And you can see the classes. So this is showing the first 5, which are Irisatosa, and the last one are Virginica. But there's a few fun things that you can immediately do. So, and I just wanted to go back here. And that is, for example, there's a dot unique. So we can select df, and then we can select, let's say we didn't know how many different classes we have in this data set. So we can do df, then we can specify that we want to access the class row, and then we can do unique, if I'm not mistaken. And we get back an array that contains 3 items, and it's Irisatosa, Iris versicolor, and Iris virginica. And now we know that we have 3. So it means that these are the 3 possible labels. And then we can filter the data frame. For example, we could say, hey, give me the data frame based on data frame dot locate, and then we can select for the rows only those rows. So the columns will want all of them, but for the rows we can say, give me the rows where the class column is equal to Irisatosa, for example. No, okay. There. Okay, control. There we go. Equals Iris Satosa. All right, there we go. Cool. And then you can see that it was able to filter out. It just gave us those rows where the class is Iris Satosa. And now we can take a look at this. So we have, 50 samples, and something that we can do, right, is dot describe. That is something that we can that we said we could do. So now we can see that for the Irisatosa, for example, the mean for the sepal length is 5. The mean for and we can do some just quick analysis, but there's I'll get to in a sec on how we can do a little bit more fancy. And looking at the time here, I think this is a good time for a break. Let's take a quick break because there's been quite a few things. From here on, really what we're going to be focusing on is this data set and plotting. But if you want to go back and revisit some of the pandas data frames or some of the other stuff, feel free to. But yeah, let's take a break here. Alrighty. So we were just looking at importing the data set of the different iris plants and trying to start to analyze a few things. So we figured out the 3 different classes that are part of the 3 different labels that are part of the data set. Then we were trying to identify or get some quick stats of the Irisatosa one. Now we can we can go ahead and do it like this and just rename this for a different type. But we're just doing it we're doing multiple times the same thing. And whenever we want to do multiple times the same thing, but slightly different way, we can probably use something like a for loop. And so that's exactly what I have right here. So all I'm doing is once again, just like we figure out what are the three different unique classes that are used. I'm storing that in a variable called classes, and then I'll be iterating over each one of those. So the first time around it's going to be iris setosa, second time around iris versicolor, and then iris virginica. And then I am going to filter, just like I did up here, I'm going to filter the data frame to create what I'm calling here the class data frame. So the data frame for that specific class. And then first I'm going to print what is the name of the iris species that we're looking at. And then I'm actually going to print the describe for that. So let's stop this. Let's clear it. Let's run it. As what we get back. So now we are able to just get some quick stats of each different type of iris plant. So for the setosa, we can see that the mean sepal length is 5, 3.4, 1.46, and then you can see how it seems like the mean for the versicolor is almost 1. I'm not sure if this is centimeters. I'm going to assume so. So in this case it's 5, and this is almost 6 centimeters for the versicolors, and then you can see virginica. The mean for the sepal length is 6.5. So you can see that it seems like on average the virginica will be the one with the largest sepal length, and then you can see how in terms of the width it seems to be different. So quick few stats that you can get pretty quickly just by using the pandas and doing a little bit of looping and unique and for loops and stuff like that, which is good. Now for us humans, I think that many times the best way to understand data is to actually plot it and see what it looks like, visualize it. And for that, we're going to be using a very simple library called matplotlib. There are other libraries that build on top of matplotlib and make charts look prettier and more fancy and all of this. But for what we're trying to do right now, I think this will do just enough. So what I'm going to do is I'm going to, I think I'll just comment this out for a moment. We're going to assume that it doesn't exist. And actually, I'll just, I'll do this. So we're importing matplotlib.pyplot as PLT. Why? Well, I would suggest that you go into the matplotlib documentation, which has been included here at the top. But essentially, pyplot is the implementation for Python, and then that is what you can use to plot. And the way it works, I think, what is the shortcut to comment lines out? It's control, and actually I'll put it here, comment out shortcuts. Put it in the chat, but it's control plus / or command / if you're using a Mac. Perfect. So once again, this implementation of matplotlib for Python, and that's how we are going to plot things. So the first thing that's important to understand is how it works. So PLT is how we've imported it as, and .plot is the method that is going to plot a certain data. There's many different ways in which you can plot data. In fact, if I bring up the matplotlib plot command, there we go, pyplot plot. You can see that what it accepts in terms of arguments are pretty much a bunch of them. So here are just a few examples. You can pass X and Y. You can pass X, Y, and then how you want the markers to look like, the color and the style. You can just pass Y. You can there's a bunch of different ways, and you can learn about everything and yeah, labels, all of this stuff. There's many variations, but I'm using the most simple one, where I'm just plotting out the data. So here we have a list, Python list. You can see that it's 0, 1, 2, 3. So it increases, goes all the way up to 16, and then it goes down. and then we plot that. Now, just by plotting, it doesn't do much. Yes, PLT will plot that information internally, but it won't actually display anything. In order to display it, we need to run plt.show. So typically how it works is that you'll create your plot, you'll do a lot of stuff, and at the very end is when you finally do plt.show. The other important thing to mention here is that if I do plt.plot, and we're going to assume that I have another data set too, it will plot them as different data sets. So this one, the first one will have a certain color, and the second one will have a different color. So we can plot multiple things and overlay them onto the same chart, and then we can just show all of it. So that's something important to mention. And I mean, you can do more fancy things, but for now, it's all you need to know. So let's run this. And before I run it, just one minor caveat of running this locally. Like, I guess if you had installed Python locally on your computer and you were using matplotlib locally versus using Replit, there's a difference, and the difference is when you run PLT show and you're running this locally on your machine, and Python is and everything's locally, it will create a new window separate from whatever you're running. It will create a new window locally on your computer, and that's where it's going to show the graphs. Now, because this is running on the browser, it can't really do the same thing. So the workaround that the Replit people have done is, and hopefully that hasn't changed, but they run kind of like a mini, I don't know, like a mini VM. I don't know, like they so it doesn't display as nicely and it doesn't work as nicely, but we'll see if they changed anything here. So it seems to be running. There we go, the output. And it seems like it was an error connecting. I was not surprised. Yeah, this is one of the not so nice things, but that is all good. And the reason why is because instead of doing plt.show, we can also do, I believe it's just save fig, if I'm not mistaken. Save fig. There's no space. All right. So then we're just going to save it as a figure. And I'm going to save it, test.png will certainly do the job. So we'll stop this. We'll rerun this. We'll give it a sec. And just like that, it's done. I'll have to move around this thing that I have here. And now you can see that, I didn't specify a certain folder or anything like that, so it just saved it in the same location. That's our test.png, and hopefully when I click on it, you can see it. And that's exactly what we should be expecting. Once again, it was rising all the way to 16 and then going down. That's kind of like what we see. I think there's a minor bump at the end from 4 to 7 and then back to 3. So this is, we plotted this very quickly just by passing one array, doing plot, and then saving the figure. As simple as that. Really, really easy stuff. Wonderful. So now that we know how to plot stuff, and we've done it into a very simple way, we can try to put everything together. So we'll bring back the code that we had commented out, Control//. And this time, I'll leave the imports all the way up. Just like that. And then I can move this to inside the plot. Okay, perfect. There we go. Instead of doing the describe and all of this stuff, I will get rid of it. And I'm going to do plt.plot. Class df will contain, I guess we'll have to select what we want to plot. So because we're going to be working with a 2-dimensional chart, we can't show the 4 features that our data set contains. So we're just going to be selecting 2. And that's what's happening right here. So once we have the data frame, I'm going to pick 2 properties, and then I'm going to use a scatter plot for it. So, actually, it's probably easier if I just copy and paste. And this PLT will happen at the very end. There we go. And this has been named class DF. So let's rename it. Okay, there we go. So we're once again still filtering and only selecting the data related to a specific iris type. And then because we have to only get the X and the Y, we only have two. Then right now I'm picking the petal length and petal width. And then we're creating PLT.scatter. Now, as I mentioned, right, anytime you do dot plot or dot scatter or dot, depending on what specific plot type you're selecting, it will be displayed as in a different color as a different data set, right? So by doing this for loop, and now that we know that there are three classes, we'll end up with three overlapping scatter plots, which is great. But it would be good to add some legends so that we can know what is what. And we can do that using plt.legend. And plt.legend will accept an array of strings with the names of whatever it is that you're plotting. So in this case, we're plotting 3 times. And those are those corresponding to those 3 class names. So in the legend, we can just specify that those 3 are essentially the names of each one of those. And that will give us a legend. So let's stop everything. Let's clear it all. We're going to save it as test just so that it overwrites that previous PNG. We'll run for a moment. I think well, actually finished running a little while ago. And it's good. So now let's take a look at this. And just like that, we can see our beautiful charts in all of its glory. There we go. So we can see that when we plot petal length versus petal width, there seems to be some sort of correlation between, the type in how big that's I was looking at the petal, and how big that petal is overall. So it seems like iris tosa tend to have very small petals, and then iris versicolor, mid-size, and virginica tend to have very big ones. So maybe this is 2 features that we can use to solve this classification problem. But as I mentioned, we also have sepal. So let's see if sepal is also an important. I'll close this. How long do you wait before making something isn't working? Mine is still running over 55 seconds. So so it's maybe what would be helpful is to do print done, because the way the console works is because it allows you to keep playing with stuff in an interactive way. It will keep running forever technically, but to be honest, the moment this yellow chevron comes up, it's done. So I can run this again. This time I've added a print statement. That way it's more obvious. So you can see that it hasn't finished running, and now it's done. It's just that it's not as obvious. And then there's a question: does it give the correlation factor? Is it just visual? Can you please go over how to read the graph, please? Absolutely. So right now it's just visual. We're just plotting stuff. We're not actually, doing any analysis or anything more fancy with numbers. Right now we're just plotting it and just visually doing a preliminary conclusion of it. And yes, the way to read it would be like this. So the sepal length is the X and the sepal width is the Y. So sepal length and width gives you essentially the size, and as I mentioned, once again, X is the length. So this would be in this case, we're looking at the sepal and then the sepal width, and each dot is a specific sample of in this case, blue is a TOSA. So out of our entire data set, we have 50 samples for each type. So the blue ones are all the 50 Setosa. And you can see that some of them, in terms of the sepal, and one of them ended up here, but most of them seem to be in this range. One of them, though, it seems like was pretty small. And for versicolor and virginica, it seems like they're pretty similar. Like there's not a huge difference, but where you can really see the difference is when you're spotting petal. I can save that. Stop this. I can rerun it. Should probably close that. That's done. There we go. So now we're looking at the petal one once again, which seems to be two features that give us a better data set for trying to classify things. So once again, petal length on the x-axis and petal width. And if you recall, right, when we're looking just at the describe, we realized that the average, the mean for petal length for one of them was almost 6, which is represented here, and the other one was somewhere around 4 point something, I believe. So that seems to match what we saw in the describe, and then that was for the length. Then for the width, you can see the range there and see that also is there. So yeah. So and once again, like I mean, we can get more fancy with the scatter plot. Like we could make one of them stars, the other one is triangles, and the other one is dots, and we can change the colors. We can add like X and Y labels, axis labels. We can add an overall title. We can add a bunch of stuff that we can do. But I mean, for all of that, I think you can go into the documentation and take a closer look at the specific the specific properties. And once again, like these are all functions. So you have your optional parameters, and then you have your required parameters, right? The ones that don't have a default value. But yeah, and I think there's another comment for anyone interested. I Googled how to label the axis. Oh, awesome. Thank you. Yes. PLT X label, PLT Y label. That's right. Yeah. Pretty much. Thank you very much. And to be honest, that's pretty much it. I know that there's a lot of content, but the truth is, it's just there's so many packages for so many things that you can do, and it all just depends on what your use case is. If you're trying to plot stuff, maybe Matplotlib is useful for you. If you're working with CSV or Excel files, maybe Pandas is the way to go. If you're doing something more numerical, like something intensive with computation, NumPy may be the way to go. If you're looking for machine learning, I mean, that's outside of the scope of today. But we actually have some workshops around that, which you can take a look at the CAC training and events, which I will be this actually training and events. I can put this link. But yes, we have a machine learning workshop. I believe this is using Python, taught by Amol. Really, and let's see when yeah. Registration is still open, so that's good. So this will just kind of like build up on what we did today. Actually, yeah, it's happened like in a week. So there you go. I can quickly copy this over if you want to take a look at that. There's other workshops coming. If you're interested in digging in deeper into those, but hopefully what you've seen today can be helpful for those workshops too. All right, and that's pretty much it. Thank you very much for sticking through this. This has nothing to do with the CAC, the Ripple platform, so you have access to it as long as the company is still working and is still going. So moving forward, feel free to keep playing with the platform. You can create your own projects and stuff like that, and keep exploring. It can support not only Python but pretty much any programming language. So feel free to do that. And if you have any questions in the future, reach out to me. I'm happy to answer any questions. And if I don't know the answer, I'll try to bring up a relevant solution or a relevant answer or someone who can answer it. So yeah, once again, thank you very much. And if you ever need to or feel like, feel free to reach out. Take care. Thank you very much.